Okay. Let's check. Okay, we are live. Hey guys, good afternoon. Thank you so much for joining. Thank you so much for joining. So this is one of the session. Every month we are planning to conduct 2 virtual event, and this is the third week's event technically, but Jan is an exception. And this is the meetup group. Please join this meetup group to get notified with the upcoming events. And today's events, we have 3 speakers. We have Renuka, Steven, and Swami. So we have three speakers in this event. So let me introduce our first speaker, Renuka. So Renuka is a principal software engineer at Itron, and she has got more than 15 years experience and very good experience in Azure and other technologies, design and development. So let's start. Hello, Renuka.
Yeah. Hi, Swami.
Yeah, Renuka.
Hi.
You can take it. Yep.
Okay. Yeah. You can see my screen, right?
Yes.
Okay. Yeah. Good afternoon, all. Good morning, good afternoon, whichever region you are in. So I'm Renuka. I'm working as a principal software engineer at Itron. I have 15 years of experience in software industry. I started as a C++ developer, and then I majorly worked in healthcare industry for 13 and a half years, and then later I moved on to Itron. Currently, I'm playing a role in software design and development, and I started working with Microsoft Azure from 2013, and it was a I worked with the Azure Classic and Azure Resource Manager. So I've seen the transition, how Microsoft Azure has changed, and it is a very good learning path that I had. And seeing the product, the Microsoft Azure cloud features coming up. So with that interest, today I would like to share my experience and my learnings on Microsoft Azure Signalr service. Okay. So I'm going to speak about Azure Signalr service. So before we go on to Azure Signalr service, let us understand what exactly RPC is about. So as the name says, it is a remote procedure call. So basically in the remote procedure call, in this technology, it is not required to know in which system the other application is running, where it need to communicate, where both the application need to communicate. So otherwise, without RPC, if I have to call a program which is running in other machine somewhere else, I need to know which address space it is running, and how to communicate, which is an API. Here also API is required, but we don't need to know which address space it is running. So let us go on to Signalr and see what advantages Azure Signalr gives us.
Great. Sorry.
Azure Signalr service is an Azure managed service. So when I say it's an Azure managed service, it is a managed service. When I say managed service, the infrastructure is provided by Microsoft Azure. All that we need to know is provide the resource name and where it is, where we want to host this service, in which geographical region we want to host this service, and then how many connections that are required for the service. So as we know, Azure provides many managed services, which greatly help for the development team to only focus on the business logic that they need to worry about, not about the infrastructure. So the infrastructure need not be created, or we need not think how many machines that I would need, how many clients are going to be accessed. So this is a great advantage that brings with the managed services. And coming back to the Signalr services, Signalr supports applications that can be deployed on web and mobile browsers, desktop apps, mobile apps, IoT devices, and you can also use for the gaming apps as well. And Azure Signalr service provides an SDK which suits for just not only for the homegrown Microsoft technologies. It supports for .NET, the .NET Core or .NET, and then JavaScript, Java client libraries are also supported. So this way, we don't need to worry about what should I do if I'm coming from a Java-based application, or if I want to achieve the real-time communication for the Java applications. And then Azure Signalr service, as I mentioned, it's a managed service. So the hosting burden is taken out for the development teams, which is a great help, as we all know, the cloud applications that they bring. So moving on to Azure Signalr service, until now what we saw is what is the advantages that we get moving to the Signalr service or using the Signalr service. Just give me a minute. Yeah, sorry. So now let us understand where we can use Azure Signalr service. So we can use an application where we need to have high frequency data exchange, and you want to have a monitoring dashboards that need to get updated, we can use it. And if you want to have a chat application, there as well we can use, and real-time updates, and you want to push the notification to a specific client application, we can do, and we can also use with the IoT and connected device. So I have used recently. I have built an application. I designed and developed an application for an IoT devices, which shares large volume of the data that get exchanged between on-premises and to the Azure cloud services. So I greatly see an advantage of using Azure Signalr service there. And Azure Signalr, why exactly we need to go for Azure Signalr services? It provides an abstraction over different transports. So when I say abstraction over different transports is, so we know Signalr service underlining whichever the communication transport that is available, it makes use of it. So if I'm not using Azure Signalr or Signalr library, I would have to take the responsibility of finding out whether server sent frames I should use, or it's a HTTP communication or web communication that I'm supposed to use. But Signalr, with going to Azure Signalr service, we don't need to worry about it. It takes care, Azure takes care of it. And Azure also supports server-side Blazor applications, and it can scale up to multiple instances. So to say, let us take a scenario that today we have 100 clients, and then later the product develops, and if it is used by multiple clients, then we don't need to worry about it. We just need to see how many instances that we require of Azure Signalr service. And since multiple instances are supported, the client connections can also be multiple as well. It can support up to millions of clients. And we don't need to, so if without the behavior of remote procedure call or the Signalr functionality, if I have to get a latest update as a client application, I need to pull my server to know if, is there any latest update available in the server, or do I need to get the data from the server. So we have all developed over a period of time. Without Signalr functionality, our client application, we have built client applications wherein at a periodic interval, they pull the server and get the latest data it's required. So which is not an effective way. Unless the schedule time comes, client application will not get the latest update. But whereas in Signalr, whenever there is an update, it pushes server who will push an update and we get the latest update. So that's an advantage that we get from the instead of polling the server. And data can be pushed to a specific client, or you can push to a group of clients. Say suppose I have, let us consider a scenario that I have an application in Southeast region, and then I also have clients in European region and US as well, and I want to schedule a software update only for the Asia region. So I can create a group of clients belong in the Asia region, and I can only push the software updates to that group. So the remaining two regions, it doesn't get an update. So this is another advantage. Instead of communicating to a specific client, you can push an update, software updates to a group of clients by logically grouping however your business logic wants to achieve it. So in Signalr, the term hub it is like a pipeline which acts connector between the client. It has a methods, and client would call the required methods, whichever it wants to make the whenever it wants to make a communication to the server, and it can connect to n number of clients, and can also send a broadcast message to all the client, or can call a specific client as well. So before moving on to the other advantages part of it, I would like to go to the demo. So I would go through how what parameters that we need to consider when we are creating the Signalr service. So as we all know, to create a resource in Azure, we need to first make the placeholder for it. So resource group is nothing but a placeholder, which helps to maintain the resource life cycle. You can delete the software, you can move the resources into another region, or you can put the software update, delete them, create them. All that can be done with when all the logically related applications are together. So resource group helps for the logical grouping of them. So let me just create a new resource group for my purpose. So I'm just going to put a demo group and the resource name. So the resource group is common for any resource in Azure. There is nothing specific about the Signalr here. Coming to the specific part of the Signalr here. So we have to provide a resource name for the Signalr service. So if you look into this part, there is a service.signalr.net. This is a DNS name for the Signalr service. So every resource in Azure has got a DNS name, which uniquely identifies the resource. So the resource name in the public Azure public cloud is service.signalr.net. It might change in case of private clouds like German cloud or the US government cloud, all those ones, or the China cloud. So this is the DNS name. So I'm just going to give some name here. I will say demo learners house demo. So here validation of the resource happens, and this name is available, so we can use it. So the region refers to the location where we want to create the Signalr resource. I would like to put into West Europe or any location wherever your application is you want to deploy, wherever you have got the customer base. So based on that, we need to create the resource, so which helps us not to have the latency. So let us put into East US or West US, wherever, assuming that I want to deploy my application in the West US. Now comes the important aspect of the Signalr service, pricing tier. So pricing tier, since I'm using so there are two pricing tiers, free and then the standard. So if you see the next to the free, dev and test only. So the free tier is basically meant when we want to explore the Signalr service before we productize it. So we can use it, or for the testing purpose only. If you want to have the less cost of the resources, then we can go for the free, whereas in standard mode it is suggested for the production resources, so production deployment. So we cannot take the chance of resource availability when application is running in the production. So we would like to go for the standard, and also the number of connections are limited in free tier. We get 20 connections only, and a unit count of 1. whereas in standard you can get based on your how many unit counts that you are going for. So each unit count supports 10,000 connections. So I'm going for a standard. If I have, for now, let us assume that I'm developing a new software. So I'm okay with the unit count of 1. When the product is getting matured and I have a number of customers coming in or using my application, I can increase my unit count as well. And then comes the service mode. So this is another interesting thing that we need to remember when we are choosing the Signalr service, Azure Signalr basically. So we have 3 options here: default, serverless, and then the classic. So the default is a default option that is given by the Azure when we are creating the Signalr service. So the default mode, it is more or less in this case, it behaves as a self-hosted ASP.NET Core Signalr service. Only the difference is in case of Azure Signalr service, the Signalr acts as a mediator between the client and the server. So both the client and server connects to the Signalr. It is just like a proxy which exchanges the data between the client and the server. Okay, then comes the serverless and then the classic. So serverless, so here if we have an application that is all the running in the cloud, say for example, it's coming into one of your blob storage, you want to get notified. Basically in serverless mode, we will use Azure Function App to run the Signalr service or your business logic. So whenever you want to have the integration with these resources like service bus or blob storage or any SQL database updates, all that you can do it by using the serverless mode. You can easily integrate. That doesn't mean that other case you cannot do. So this is more of easier integration that you get with the serverless mode. Only thing the serverless the difference between the serverless and then the default mode is in case of serverless, it becomes it is the responsibility of the application to manage the clients. And then the classic. So classic is a mixed mode. So it will have both the default and serverless support as well. So now I'm just going for the default, and later I will come back and show the difference between the serverless as well. Okay, so let me create a service. At the time of provisioning the service, many of us know this. So Azure has come up with an option of giving the template, so which will help us to build a release pipeline and use these templates. Basically, template is nothing but a JSON representation of the resource, and you can as is take this one and customize if you want, or you can integrate with your release pipeline whenever you want to deploy the resource in different geographical locations, just by changing the parameter of the location and then the name of the resource. So now my Signalr service is getting provisioned. It would take a few seconds to provision the resource. Let me go to my resource group meanwhile. So if you see here, I have the resource available, and this is a Signalr resource icon. And let me go to my resource now. So if I go to the resource, these are all the parameters that tell about what events that resource has got, or we can tag it. But the important thing, in order to use the Signalr service, what we need is a connection string for the resource. So in order to ensure that the resources can be, the connection string can be exchanged for security purpose, every resource in Azure now has got 2 connection string, primary and secondary. We'll be using primary, and if you want to have the shuffle of the connection string, you can keep it in a secure location like a vault and shuffle them also. So that's a advantage of these 2 keys that we get it. So now moving on to the application, I have prepared for the demo purpose, I kept my applications ready. So first I'll go to the Signalr application. This is I'll be using a Signalr service which is created in the default mode. So let me go to my app settings, Jason. Nothing specific I have got here. So moving on to so here it is an .NET Core application that I'm using here. So what exactly that we need to use in order to make use of the Signalr services? You just need to um, inject the Signalr connection string. So the first thing is mandatory that you are saying that you are using Signalr, and on top of it, I want to use Azure Signalr service. So I just use the add Azure Signalr service. So we get it using the Azure NuGet packages. So if I just go over here, if you see the package that I'm using is Microsoft Azure Signalr. So 170 is the package, NuGet package that I am using. And here I am explicitly giving my Signalr connection string. You can put it into your application setting. So other than that, in your startup, application startup, the connection string is the important thing that you need to provide so that your application knows to which Signalr service it need to connect. And then the second important thing is a chat. The hub name. So hub here I am calling the hub as a chat hub. This is a class where I have got the hub implementation, and then I am exposing with a /chat my hub application with a /chat endpoint, so that whenever a client, any application wants to communicate, so I can communicate it to this endpoint, and Signalr exchanges the data between these two, any application that trying to communicate over this API. So now moving on to hub, I just have got a hub implementation in this chat hub class, and I just have two functions which implement the broadcast message, where the main important thing here is I am trying to send a message to all applications. This is like, say suppose you have got a downtime of your server. You are trying to update client software, not in the Azure, they are on the customer premises, and you would like to update your software and so on. Say date, say suppose next week Sunday you want to update, and you want to notify your customers well in advance. So you can keep broadcasting the messages to your customers. So that's the one thing. Or you want to send some latest update that you have got, immediately you want to share with your application, that you can do it. So since I have mentioned about broadcasting, so I would like to mention where exactly in real time I used. So we have an application which runs an on-premise, that is in the customer environment. They run in a tech environment. So what exactly it means is they are not exposed to all the endpoints. They do not have all the network endpoint access. But we want to control those machines. So what software is running, whether the software is healthier or not. All those things I would like to know instead of when customer reports me. So for that, what we did is we have added a small lightweight service, Windows service it is, which will connect to my Signalr service, which is running in the cloud, and keeps sending its health checks on a periodic basis. So that way we get to know what the state of the software. Other way around, I have some configurations for the applications and the customer would like to change those configurations. So we also send from the server to the client. So both the way communications are possible. So the reason of mentioning explicitly this is it is not just meant for the application that run in the cloud only. Wherever you have restricted environments, it can also be done. It is safe to communicate, exchange the data over the cable, over wire. So these are the APIs. As I mentioned before, there are APIs to send a sync. Send is there, so you can send it to all, or you can send it to all except. You can do so. All except means you don't want specific client to be notified about them. You can use all except that connection using the connection ID, or you want to send all client, you can do that also. So if you see, when I was mentioning about the group, I mentioned about if we want to update the software in Asia region, we can do that also, or US also, using clubbing them with the group that you can do. Say suppose you want to do an update of Europe and US region together, but not the Asia region. So you can use that time group except. So these are all the very good functionalities that have been provided, which very well suit for our real-time needs of the application. So we can use Signalr for that purpose. So let me try to run this application and see. I just made a simple chat application. So I made use of the examples. If you just go to Microsoft Azure docs.microsoft.com, it has got very good documentation. So try to I took the scenario and I just tried to customize for my purpose here for the demo purpose. So this is a simple chat application like our Yahoo Messenger or any other messenger, how it happens, right? So when we join the groups or any group that you join, you join this group or this user joined. So those kind of messages comes, right? So I just try to use the same thing. Now let me duplicate so that I can get another instance over here. You can just that identity that I wanted to give. So I gave here. So now if you see here, other users get to know whenever the others are joining, and you can also send the broadcast. So this is happening basically whenever user is joining, there is a broadcast that is happening internally. So that's the reason users are getting to know. So I would like to say, hi, welcome to demo. And then I would say send message. So it will go to the all. So it has come to this user also and this user as well. So you get to know who has given this message as well. Okay. And if I want to say that explicitly I am the person, I wanted to say something, I want to echo. So I can say, you can also do that. Means you will get to know who is doing this echo as well. I just call it here, it is echo. So basically, if you want to send to a specific user, you can do that. You want to send it to group, broadcasting also can be done. So this is one example where I have used Signalr service in the default mode. So now I go back to my application. Okay, so if you go to the settings, you get the mode that the Signalr service is currently running on. So as I mentioned, there are three modes here: default mode, serverless, and classic. I showed the default mode. In default mode, Signalr service acts as a proxy between the two clients. So here I have two browser applications which are exchanging the data. So the data exchange is happening through the Signalr service. So I'm not responsible here to host the hub application. Okay, so now for coming to the serverless. Now I would like to change my Signalr service to a serverless mode. So I just change it to serverless and I save the application. Okay, so let me go back to the example that I have already prepared. Okay, so here, as I mentioned, generally for serverless applications, the Azure Function App will be used. Before going into the application that I have created, I would like to show the triggers that I have told before. So that can be integrated with the Azure Function App. So then I would call it as a Function App 1. That's fine. We are more interested about what options that we have got. So say suppose, let us consider the scenario. You have a client application, would like to make an HTTP request, REST API request or HTTP request. So you can use the HTTP trigger in that case. And once the request comes, you want to notify all your connected clients saying that there is a message I want like to broadcast. In that case also we can use Signalr. Or you have an blob trigger. Say suppose one of your application puts a content into the blob and you would like to get notified, then you can also trigger with the function app with this block trigger, and then make use of the Signalr for the other business functionality that you want to do. The same with the Cosmos DB, event trigger, event hub, all these are all the options that where you can use this. So going back to my application. So I have created my function app and kept ready. And let us look into the local settings.json file. This comes by default when we create a function app. So only thing that I'm more interested here is I want to provide my Signalr connection string. I had already created and kept my resource, so I'm not using the one which I have created now. There is no difference, exactly the same way that I have created. And most important thing is you need to provide Azure Signalr connection string, so that whenever your application comes, starts up, it will be able to communicate with your Signalr service. And then going back to my function app, so I just have business logic where I wanted to place an order, and I wanted to track the order or notify the customer, or say suppose it's like an Amazon application, right? And I am providing some clothes, or I'm hosting my business for clothing business in the Amazon, and I would like to know whenever someone places an order. So in that case also we can use the Signalr basically. So I just tried to explain with an example so that it will be useful. So I made the same example over here as well, and I'm calling my function name as a new order. And whenever an order is placed, I would like to see in my UI that a new order is placed. So how can I make use of it is, let me first run my application. Sorry. Yeah, I wanted to run my function app. So let my function app come up. Okay, so if you see here, I have two methods that I have exposed here. Negotiate is Signalr behavior that I'll go there. Before that, I have another API that I have exposed here. Whenever a new order is placed, I would like to place that this API will be called by some client application, and then I would like to get a notification in my UI. So for that purpose, what am I doing is I'm going to use my Postman as an through Postman I'm going to place an order. Now let me meanwhile start my UI application where I'm going to see the notification whenever an application makes a call to this API. I would like to know order is placed. So this is another client application. So if you see here, there are no orders as of now because I did not make the API call yet. Okay, so if you see here, this is an empty one. And I would like to go and place an order now. Okay, so the API returned 200. Okay, so if you see, new order is placed. So how is it? I did not make it. See, I'm basically making an API call to my function app where it is hosting this API new order. So, but my client is running in a different address. My function app doesn't know where other clients are running. So as I mentioned, the advantage of the RPC is we need not know the application where it is running. We just can communicate with them. So you can make a number of calls. So you just get notified in the client application. Okay, so I just pressed 3 times. So now let me stop. Let us go back into our function app again. Okay. So the NuGet package over here, let me go to the NuGet package. The function app is nothing but more or less if you're familiar with web jobs, which was used for running on a periodic basis or continuously running whenever there is a notification coming. Then we were using web jobs. Exactly, the function apps also work in the same way. They work more on with a trigger based now. So the package that I'm using is web job extensions Signalr service. Yeah, coming back, so I have the function here, and then if you see, I created an HTTP trigger. A few minutes back, I was showing the triggers that are available. So I took a HTTP trigger. That's the reason I'm able to call through Postman, and the request is coming to this new order. And then I wanted to put the message into the table storage, and I wanted to notify the application through the queue. So that's the reason I'm using a table trigger and queue as well. And as soon as a new order comes, I'm just saying notifications.add sync, and then I'm saying an order placement. So as soon as the notification happens, so it will send that product is ordered and the notification will go. So if you just go back to my function app console, you can see here sending a notification whenever a request comes, executing new order, and then it is sending a new order notification. And so we get to know basically whenever an order is coming, the API is getting called, internally it is notifying the clients. So at the time of the notification, the service is not aware of its client which it is sending. It's basically sending to an client whichever is connected as to the Signalr, Azure Signalr service. So if I just look into Signalr Messages, if you see here, so adds async is the one which will help us to send it through the a message to the connected clients. And then here, if you see here, as I was mentioning, the advantage of going to the serverless, when we want to maintain the hub, then you will have to go for the serverless applications, or you want more control over the hub, you can do that one. And here my hub name is a notifications hub. So whichever application gets connected to the notification hub, they will get the message. My website is connected to the notifications hub. That's how it is getting to know that an order is getting placed. So if you see here, it is connecting to Signalr Hub Connection Builder and to this API. And whenever a product is ordered or whenever it is getting disconnected, say suppose if the client gets disconnected, I would like to know to my server, that is also possible. So these are all the examples that we can use with the Signalr service, where we can use of the Signalr service. So I explained the default mode, I explained serverless. So we can use classic also, which is a mixed mode kind of thing. And if I just go over the other parts of the Signalr service, here is you can get an integration with the identity. So if you want to have an integration, or you want anyone to whom to access, who doesn't want to access, you can control it also. You can put the Signalr service behind a network using the private endpoints. All these are possible. Or you can allow which are the endpoints to be connected. That's also possible with this to the Signalr service. You can allow, disallow, all these are possible as well. So that's about the advantages of a Signalr service and how to use the Signalr, Azure Signalr service, what all the modes it has got. So moving on to the Signalr and GR versus gRPC, since in this forum, gRPC is more spoken, so I thought of differentiating between these two services as well, Signalr versus gRPC, when to use Signalr and when to use gRPC. So Signalr is a pure HTTP based communication. As we all know, gRPC is a HTTP2 based communication, and Signalr uses the message pack approach, and in gRPC it's a protocol buffer approach is used. And in case of Signalr, both client and server can communicate. So that means, say, suppose a specific client wants to say, this is more we have seen in chat applications, right? So I am one of the client and I want to talk to a group, I can do. I want to talk to a specific person, I can do. And the server wants to send a broadcast notification to, for example, I want to shut down all my servers. I want to send a broadcast to all my clients. That also is possible. So both the way communications are supported in Signalr. Whereas in case of Grpc, it is a client driven. So client has to communicate whenever there is a request or communication required. And in Signalr, there is no upfront contract. So you, as I was creating an application and going through, right, I never defined a specific contract in Signalr applications. Whereas in comes to Grpc, we have to have the contract defined in our protofile. So the protofile has got a specific format and we have to follow the message format, protofile format that we need to define. The messages, what we are going to use, all that need to be upfront defined in the protofile. Whereas in Signalr, that's not required. Yeah, that's all I had for today about the Signalr service, advantages of it, and where we can use the Signalr service, and how to use Azure Signalr service. So here for the demo, I just hosted the application locally because I have the Azure tools that are installed in my machine. But in for production usage, you can deploy them into the cloud, Azure cloud, just by using the publish option or through your release pipeline. To show more the demo part, I just hosted locally.
Hey Renuka, thank you so much. It was really wonderful session, and there are a couple of queries, Renuka.
Okay.
So we
Yes,
can,
one.
yeah, we can go over one by one. There are three from Dolly and one from Prasad. Prasad's one I didn't understand fully, but we'll try to
Okay.
uh, understand and answer that. Okay, so the
Okay.
first query was what is the purpose of two keys and connection string?
Okay. So let me go back to the resource now. Okay.
Okay,
Say,
Prasad's this thing has been answered. It seems cool. Mm,
okay. So
mm.
Swami, shall I go over
Yes,
this
please go
question?
ahead. Please, yes, please go ahead.
Okay. So
Mm.
every resource in Azure has got two connection strings like storage. These resources wherever we have the data, and say suppose for any reason this key is got compromised, we don't want to have the data lost to occur or someone to take our data or connect to these resources. These two keys are used. So basically, I'm using this key, for example, key primary key or key one I'm using. Now, as part of the secret rotation, these are secrets basically. So when I want to rotate the secret, I don't want my application to go down. So in that case, I can make internally my application point to secondary key and I can regenerate the primary key and vice versa. So that way the secrets cannot be compromised and application will not go down when you are regenerating the keys.
Okay. So the next question is how can we achieve real-time features for Windows-based apps?
Uh, Anything
Maybe she's
specific?
maybe she's trying to ask whatever the Signalr features you showed against the um, uh, against this one uh,
Uh-huh.
website.
Okay.
So how can these things can be used on the Windows part of the world? That's what I'm reading based on that
Okay.
query.
So let me go over the real time where I have used and we have seen an advantage of it is we have an application which runs as a Windows service which exchanges the data between the cloud applications and on-premises machines. They are basically IoT devices. So for this application, we have got some configuration. So the configurations are huge. We cannot go and edit manually. So we have provided an UI for it. User can go and configure them in the UI. And I want to push those configurations. So their Signalr is used. And other is I want to do software updates to this machine, which we are using the software updates also through Signalr. And I want to do health checks of those services. I would like to get notified when my application, which exchanges the meter data, basically where meter information is collected and it is put into the cloud. There also we are using Signalr. So these are all the real-time uses where I have used Signalr.
Okay. Have you used Azure storage for this demo? That
Azure
was
storage, I have not used, but if we want to go with the blob trigger, right? Say, suppose I have an application which will put a content into the blob storage. I would like to get notified about it. Then we can use a blob trigger. Function app will get triggered whenever there is a data upload that happens to blob, and then we can use Signalr there. I just used a HTTP trigger because I wanted to make an explicit API call, so I just did that. We can use
okay.
service bus to anything that we want to have.
Okay. Cool. So one more thing is, when should you use the gRPC in real-time scenario? That was one query from Dolly.
Okay. Maybe Swami, I think you are the right
Yeah,
one to.
right. So Dolly, I will take this query. So as I was mentioning in my gRPC talks, so the use case is like when you have a low powered IoT device, or when you have two services which has been deployed in two different data centers and they both want to communicate, where you don't have the user behind the system. So two softwares talking to each other, that could be one place where you have to use it, or where you want to develop a microservice, and instead of going ahead with the REST API, you want to go ahead with this gRPC. You can definitely do that, but you need to do a thorough performance testing before choosing one over other, because each of these technologies has got its own use case. So one more thing is where you have two companies, they are either doing the working on a big project, or they are doing a merging of these two applications, and one company is using a set of two language and different operating system. I mean, uh, one guys are one set of users are using Ubuntu and purely Go language, and the other company is using Windows and the C# language, and they both want to integrate their microservices, so they can do that. So there are different use cases are there, but before choosing anything, we have to carefully do an analysis. We have to carefully do the analysis, like, are we getting the right performance, because the maximum message size of grpc is 4 MB. If something goes behind that, then you have to bump up the size, and if you bump up the size, there might be a negative memory impact. So you should do a little bit of careful analysis before choosing one over other. Okay, so another query is from Manikanta, I think so. He was asking on unit testing the apps that use Signalr services.
Mhm.
So,
I didn't get Swami.
yeah,
How do we do?
so
There's
he's
a
telling
question.
that, Renuka, can you please share your thoughts on unit testing apps that uses Signalr services? So I'll try. Just correct me, Renuka, if I'm missing something. So what I'm assuming is, as the services, we all push these services to a different layers, like a library which is talking, which is communicating with the Signalr. So when a class from library A is talking to class B from library B, and the
Mhm.
class B in library B is communicating with the Signalr. Let's assume in that case. So whatever the
Okay.
unit testing we are doing, we will do only with the class A's method.
Correct.
So when we do the class A's method, so we just mock the class B or the library entire library itself.
Okay.
So we need to mock it properly. I mean, if you are unable to mock it, that means we need to refactor the code. Uh, am I
Yeah,
making
it
sense?
is. Yeah, the same thing holds good for any other resource as well, right?
Right.
Even for
Exactly. Exactly.
for that matter, need not be Azure services. Any application, each unit that we are writing should be mockable, testable.
Exactly. Exactly. Oh, you are testing a unit of code. That means
Yes.
5 to 6 lines are a maximum of 20 lines. If a method goes more than 20 lines, that means you have to sit and refactor that method. So a screen full of content, maybe realistically 15 to 20 max lines. And some of the things which is coming as part, you're invoking a method. That means you're not doing an integration testing, you're doing a unit testing. That lines you're testing it. So technically you should be able to mock it. Anything, if you're not able to mock it, then I think that there'll be a little bit of refactoring of code. Hope we have answered your query, Manik. And one more thing is, if I want to broadcast notifications to users logged
Mhm.
into web application like React, which
Mhm.
works best? Which okay, he's asking whether Signalr works or grpc works. If I want to give a notifications,
Signaler works.
Signalr is the one, Prasad.
Yes.
So I think there are no more queries. Manik is done, and Prem and Dolly was talking. That's it. I think that's it, Renka. There are no more queries. I think we have addressed all those comments and Prem. Okay, so
Okay.
that's good. That's pretty good. And really, thank you so much for your session. It was really wonderful session, and this is giving me a little bit of confidence that I should be able to do some work in Signalr. Okay, so the next session is by me.
Okay. Yeah.
So
Thank you. Thank you all for joining the session. And you can reach me out if any questions are there further on Signalr or on Azure topics on my LinkedIn or on my Twitter. So I'm active on LinkedIn, so you can reach me out there. Yeah. Thank
oh,
you
you
all.
can post it in the comments, Renika, your LinkedIn
I'll
and
do
Twitter.
that.
Yeah, you can post it here so that
Hmm.
folks will be able to reach you. Okay.
Sure, Swami.
Thanks so much.
Yeah. Thank you all.
Yep. Hey guys, thank you so much for joining, and let's start with second session. And Steven is from US, so we moved his session. Technically, Steven's session was second, but he's from US. It is a bit early for him, so I just I'm taking this session, and the next session Steven will take. And this is the session on Web API using .NET 5. As we discussed in the first session, this is session 2 of 15. We have planned 15 sessions, uh, 15 sessions on Web API. We'll be covering lot many things in this series. So again, I have given the softwares and tools and basic knowledge on C Sharp, PF Core, and a little bit of async about at least what it does. And then we will have this data store. I'm using Azure. Just give me a minute. Let me log in. Okay. So this is the same. Uh, this is the same data store which we are having. We used it in our previous session, so we'll be using the same data store, the professors. Okay. And the technology stack again, it's .NET 5 SDK, Web API, and Blazor WASM. And Angular we'll see in next session. It's like we learned some piece of Web API, and then how do we use this Web API? So it's only 50% of the story when we do a Web API. So another 50% is how someone is consuming it. So we'll be slowly looking into Blazor WASM. A lot of single page applications will use or will integrate with. So we'll initially we are starting with Blazor WASM. Then in the coming sessions we'll start with Angular 11. If Angular 12 comes, we'll work with Angular 12, and then React. We'll do the same application in different SPA applications. Then you know that how each technology communicates, or what are the things you need to consider before using that technology. Okay, so and all the sessions will be on hands-on, and we'll be having the parking lots. If I'm not able to answer any query uh, in this session, I'll definitely go back, read some more topics on that, and then get back to you. uh, okay, so I'm learner. If I miss something, I apologize for that. So what we'll be doing today, so today we'll be building up a little bit of fundamentals. Some of the things what we will do is we'll introduce a concept, and then come back in the future sessions and again revisit the same. Like example, I'll just quickly take one small thing, and I'll come back. I just want to show one small piece. So if you see this HTTP status codes. So in this HTTP status code, there are a lot of things like what all the informational success responses, redirects, client errors, and server errors. And if we are going to talk everything in this session, then we might not know that when is an exact thing when we use it. So at least we'll introduce what it is, and we'll worry or discuss only about one point. Okay, why I'm sending 200, and then we'll stop it there. We'll go back with our session, and in future we'll come back, and when we want to throw 500, or when we want to do something else, so we'll come back. Like client errors, you miss some authentication piece. When do you get this, you send a model which doesn't fit, then you get this bad request. So we'll come and learn that. So if you are introducing something and we discuss only partial, that does not mean that we are shutting down the curtains. We'll reopen that topic again in the future session, and again we'll discuss. Okay, so we'll be discussing about the resource naming guidelines a little bit, and see the action written types and the status codes. And then we'll start building the application in different layers, the classic three-layered approach. And then we use user secrets instead of the app settings. And then we'll again go through this dependency injection, and then we'll do the cars. We need to add this cars, and then testing using this Chrome browser, Swagger, and Postman. And then we'll do an integrating web API with the Blazor WASM. Okay, so these are the things, and we'll be testing with Swagger as well as the Postman, and then we'll develop a small Blazor WASM application, and then we'll do a quick integration with the web API, whatever we are developing. Okay, so the entire code for this session will be available here under the speaker series. So 30th Jan 2021. So this is the thing. So some of the things, some of the check-in, I need to do it here. So I'll do it by the end of the session. So please make a note that this is where you'll find this session. Okay, the source code for this. So keep it handy. So I'll come back to that. Right. So let's start. Let's start. While the Visual Studio is opening up. Okay, we're opening up the previous solution. This is what we have achieved till in the first session. So this is the second session. So whatever the state of the first session, we will work from there. Because what did we do? We have created different folders and saved all those files here in the folder. So technically, if you see that we have only one one project in this entire solution, right? So you can see that we have this folders, and the entire thing is in .NET 5, and we have different folders. So now we need to create different layers. So we'll start. Okay, so as we have discussing, so we discussed that anything which is pretty much common will be in application core, and something which is related to the data access layer will be under persistence, and anything related to the business logic layer will be in business logic layer. So let's start creating those projects, and we'll take it from there. So the first thing what we will do is, first let's run this for a moment, and then uh, we will move code, and application will not work for next 15 to 20 minutes. Do not worry, we'll bring it back to its original state, working state, but it will take a little bit of time. So let's hold on. First, let's test that it works. So let me come to this weather, and I click on execute. You see it gives the weather, and here you have Manish Agarwal, Mithun Nair, Scott Rudy, Sandeep, Shiva, Matthew, and Azim. So a lot of people are there, and here let's come to the professors. Let's try that, and you're seeing that the content, it returns this content. So now application works. So let's build little bit of theory before we start moving the code left, right, and center. Okay, couple of points is resource naming. So because a lot of documentation is there in on net, I didn't worry to recreate the same thing, because we can directly go and check that. So while creating the resource naming, so there are a lot of best practices. Okay, so one of the things is always use noun. Okay, so instead of saying this get user, so it's better to use this nouns like users, or if you see this, it's all like a collection, like set of users or set of employees or professors or books or authors. So those kind of things you have to pluralize also. Okay, we need to have this nouns, and also best to do pluralize if you're returning a collection, and then from that collection you're returning a particular resource. Okay, couple of things is URIs as resource as nouns. Okay, and also we need to do the pluralize. Like suppose if there are multiple users inside that, one of the users ID will specify like employee. So employees slash 101, that's an employee ID, slash address. That means what technically what is happening is, from the list of employees I'm going to employee 101 and returning his address. So that's like, here you have pluralized, but we are retrieving the content which belongs to a particular employee. Okay, so no slashes after that, forward slashes hierarchy. And one more thing is, we can have the query string. We'll come back to that query strings, but at least for today's session, let's understand this. When we want to do retrieve a collection, we'll be pluralizing, and we use nouns. Okay, so and also if you want to retrieve a single entity from that collection, we use that pluralized slash one particular ID, which uniquely identifies one of the resources from this collection. So for this session and the next session, these two things will be good enough. Like we will have professors and get professors by ID. We'll have one ID. Okay. So for today, we will stop till here. We will have collection, right? So and we'll come back and revisit that, and also like no technical jargon. Like if you see this pan, so it will be knowing only to few people. Like one of the example is different countries will call uh, the same technology terminology, or the same term will be used in different sense, like zip code or pin code, or different countries will might call it in a different way. And also no shortcuts, so better to have a full form so someone will know that what exactly it's being done. So no trailing forward slash and no extensions. So these are the some of the best practices we need to follow. Okay. And action return types. So action return types is, we'll introduce and we'll again come back to that. So if you see the two controllers here, one of the controller is this weather forecast. So here in this weather forecast, we are clearly telling that this weather forecast is going to return a specific type. What is that specific type? It is an one or more of this weather forecast model. So that is over here if you see. So there are a couple of things. We'll introduce two things and we'll come back. Okay, so this is a specific type. Okay, the simplest action returns a primitive or a complex type. So this specific type, it says that, okay, I'm going to return list of product. Okay, I'm going to return I enumerable of this one. So here also in this example, you see this I enumerable of weather cost, weather forecast model. So you can see this one I enumerable of product, and here we are using this I enumerable of weather forecast. And if you come to this processes controller, here what we are doing is we are telling that action result. So if you go to this action result, uh, you can see this here. Let me expand this. So a type that wraps this action result, and we'll see some of the advantage of sending this I action result. So I action result, when you're returning this I action result, we can send multiple things. Like we'll see in our example, what did we do here in this processes controller. We are sending that okay object result. So you can come in and see this okay object result. And if the collection itself is empty, we can send that not found result. So there are no rows in the database, so we can send this. Or or if it is a post method, the user did not give us a valid model, so we can tell him that one of the client side error kind of thing. So we can tell him that the bad request, so whatever we are expecting is not sending that particular model, so we can tell him that. Okay. So two types of action methods. So one is results. So one is the specific type, and one is this I action result type. So when it is specific type, no matter what, we have to definitely send this as an output. But when it is an action result type, then what happen is it could be anything which which it accepts, like okay results, or a not found, or different kind of things. Okay. So here the first thing what we are using is this okay. So when we are sending okay, so that returns the 200 status code. Now what is the status codes? So status codes, the HTTP status codes are different types of status codes. Like if you see that informational, or a success, or redirects, or client side errors, or a server side errors. Okay. So for today, we will learn only about this. 200. Okay, only about this today we will learn. We'll come back and we'll learn these in future sessions. Okay, so when the request is succeeded, so if you see this get method, so it could be used for put and post, but some people they use 204 also, but we'll come and discuss about that in which scenario we'll use it. Okay, so in when you do a delete or put, some people tell that we can use 204. And here if you see this 200, okay, you can send it for get, and put and post the results describing the result of an action is transmitted in the message body. So when you're saying 200, okay, we will send the newly created resource or an updated resource as part of the message body. But as far as today's session is concerned, we are sending 200, okay, when we receive a get request, we are sending 200. Okay, so that you can see here. When I do this, professors, did I stop it? Okay, it is in execution mode. uh, okay, what is the, that's 5001. We invoke it, so you can see this 200 status. Okay, and let's go to the weather. You can see that status code also here. And if you go to this weather, again you can see this, we made the request to this weather API. And this weather API is also returning the 200 status. Let's see that from the postman. Weather forecast, you can see this one is also returning. So we understood couple of things. One thing is we understood the return types and little bit of resource naming convention, the endpoint naming. We understood what is the HTTP status code. That means when you invoke a endpoint, what happened, or the server or the web API is communicating back to us saying that okay, um, everything is good, I'm going to give you the results, or I could not find any rows, I'll give 404 not found, or there was an exception, I give 500. Or when you're trying to post, create a new resource or update an existing resource and you didn't send the proper model, we will send 400 bad request. So that we have learned. So let's quickly see what did we touch upon. We spoke about resource naming guidelines. We spoke about a little bit of action return types. You can return the specific type or I action result, and the status codes. So each of a method we can send 200. And what if there is an exception happens? So whenever there is an exception happens, so we can send the 500 error. So that exception that we will see in the next session, but let's focus on this one particular method and how can we integrate this with a Blazor WASM. So that's about this one. And also, when do you accept input as part of the body, that also we'll see in the next session. Not this session, let's stick ourselves to these items, whatever we have planned to do. So the first thing what I'm going to do is, now you can see this application is working. I'm going to destroy this and make it in a non-working state, and then we'll bring it back. The first thing is we are creating a new project, and that project is library project, um, .NET Core library, and I will call that as core. I'm going to call it as core and drop it here. Let me click on create. Okay, we have created this core. So it is using 3.1 framework. So let's make it to .NET 5. Okay, so that's one thing. And the next thing is we need to create two more projects. All all three are libraries. So we go ahead and use .NET Core, and this time it is DAL, Data Access Layer. And another project, let me create that. Business Logic Layer. Okay, so we have created all these three projects, right? So the next thing what we will do is, let's go ahead and add the project reference, because this needs to use all these three. So I'm going to add that. That's the first thing I do. And the second thing is we'll go and fix the target framework. We want everything to be .NET 5. So we changed it, and I think core we changed in the uh, previous step. Again, I'm coming in here and I'm changing this one. So now we have created three different library projects, and all three are .NET 5. And what is that? Oh, it shouldn't be. I created a wrong project for this DAL. So let me delete that. One second. I'll remove that project. And I have to come in and delete it from here. Looks like I just selected the console app, because that's what it's showing on the top. Yep, here it showed it. So it should be a library project, DAL, and select the folder. Let me go to end. Okay, it is in source. So let me change. So cool. So we have all these projects. Everything is .NET 5. So we have three libraries and one web API. So let's fix step by step. So the first thing is we want to build this core. So what does this core has got? So the core should contain the common, the constants, as well as it should have entities, and then it should have interfaces. So it should have these three things. So what I'm doing is I'm cutting this and pasting it over here, and then I will cut this entities and then paste it over here. Okay, so now our application, we have broken our application. It will not work, but we will fix it one by one. Now if I come in over here, that the namespace should be core. So let's fix the namespace. Okay, so the namespace is college core constants. No, the namespace should be common. So college.core.common, that should be the namespace. And for all these entities, it should be under that library / entities. So let's fix that. So let me come to student, and it should be college core and this weather forecast. Perfect. So we have fixed it. And the next thing is This is college core common, right? College core common. Yep, we fixed it. So the next thing what we will do is we'll go ahead and create the interfaces. So right mouse click and we'll create a new folder, interfaces. So the interfaces will be uh, we need two interfaces. One is for iProfessor SQL DAL and iProfessor BLL. So we need those two. So we need to have an interface. Okay, we need to have an interface. I am creating iProfessor DAL. Okay, that's one interface, and we need another interface, and that will be BLL. So we have two different interfaces, and these two interfaces will give the definition. It should have the declaration of this method, whatever we want to support. So we want to support this one, get all professors. So let's come back over here, and I'm making this as public interface, and I am so it needs this that's within the library, so it is using that. And let's remove this unused usings. So we have a public interface where we have one method we are exposing, that's task enumerable of professors, that this is get all professors. Okay, so our DAL interface is ready. So now let's go to the BLL and let's bring in this. So we have our two interfaces are ready. So we are good now. So from the core perspective, we have everything whatever we need. So we have this common, we have this entities, we have this interfaces, and ensure that college core interfaces, that's the namespace. College core interfaces, that's the namespace. Here college core entities, college core entities, college core entities, and this one will be college core common. So I think we are pretty much done with that. And what we have to do right now is we'll cut this guy and bring in into the DAL. We'll drop it here. Okay. We dropped it inside the DAL, and it should be college DAL. It should be at the root level. As I was mentioning, nothing will work, folks, but let's hang on for 10 to 15 minutes until we fix everything. Okay, and this will be inside the persistence. Okay, so the college.dal.persistent. So that's pretty much, and we need to have this NuGet of this, bringing in that NuGet over here. Let's bring in that NuGet. Let's go and check the dependencies inside that NuGet package, and we have installed it 5.1. So now what do we do over here? Let's go to this college core common entities interfaces. This is not needed. I'm deleting that. Okay, good. And now we don't need this guy. I'm deleting it. Now let's fix the code over here. So the first thing is, so we have these things which we have to reference the core. So let's add the project reference. So we need to refer this core, and then we'll bring in this guy. Okay, so that's pretty much. So it fixed it. So we don't have any squigglies. And let's come back over here, and I do remove whatever is not needed, and then I will add this dal persistence. So that's being referred, and this professors, they are coming from core. So you can see that there is no more red squigglies here. So all these things are good. So yep, this looks good. So we fixed the data access layer also. And for this business logic layer, we have to cut this guy and then paste it over here. And we need to bring in college BLL. So that should be it. So that one namespace fix should be enough. We'll remove this class, and I'll come back over here and remove the things which we don't need it. So let's bring one by one. We need to refer a couple of things. We are using that and these two. So we need dal as well as the core. So this is coming from the data access layer, and iLogger is from Microsoft Extensions, and this professors, that's coming in from college core entity. So now we have moved everything to different portions. So you can see that uh, we have one final round of verification. So we have constants and we have professor. So we don't have any unnecessary usings. That's what we are checking. So we don't have any piece of code which is not used. And interfaces, we have one interface here for business logic layer, one interface for data access layer. So we are pretty much clear on what the application core is, and then we are going to this persistence where we have this DB context, and there are no unused usings, pretty much the same. And we have implementation for the get all professors. So we have everything in place. Perfect. So, and the business logic layer is also same. We don't have any unused usings. And here this we are invoking the data access layer. So that's it. So we have moved all our code into different layers. Now let me clean this up a little bit. I clean it up. So perfect. So let's build it. It will not work. There'll be a lot of errors. We'll fix it. It doesn't take much of time, but it is pretty much a little bit of changes is needed. So the first thing is we'll come to this startup and we'll remove everything there. So all the unused usings are gone, and here in the program class also there is no unused usings. So we'll go and fix this startup there. So the first thing is we need to bring in this constants. So where is this constants coming from? So that should come from college core common. So that's where constants data store, here it's going and getting it. And this DB context. So the DB context is coming from the data access layer persistence folder. And here the Professor's BLL is coming in from the business logic layer, and the professor's DAL is coming from the data access layer. Okay, are we done? No, we didn't. There's one more step to go. So that step is what? Here we are depending on a concrete implementation. That means here we are directly dependent on this guy. So imagine a scenario where you are integrating with the payment gateway or some gateway which is exposed by the third party. And most of the scenarios, what will happen is they will have version, one version which is going all the way till the UAT, and prod they'll have another URL, or one step besides, one step behind this UAT. Like if you see dev, QA, test, and stage, they might have a stubbed in or the demo instance where we go and communicate, and the production one for UAT and prod will have, they'll expose another environment. So in that case, what happen is if you go by this kind of thing where you do a concrete implementation, then every time you go from environment to environment, when you're switching from demo environment to the prod environment, you need to do the code change. Instead, what we can do is we can implement an interface, and if debug or some kind of, if the environment is dev or if the environment is prod and UAT or prod, use the full implementation, and if not, use the stubbed implementation. So we can create two classes. One is Professor SQL DAL, this for UAT and prod. Professor's stubbed SQL DAL. So that's for dev, test, QA, and stage. So we can put this branching over here. So what we have to do is we will go ahead and we'll tell that if someone asks for this particular interface, give them the instance of this. So let me bring in the interfaces, and similarly now we are depending on the interfaces. If someone asks for this, give him the implementation. So this is iProfessor, this is iProfessors, and similarly this should be implementing that interface. Okay, so now this iProfessors DAL and iProfessors BLL, those two are implementing an interfaces. So the advantage of that is we can depend on interfaces instead of the concrete implementation. As I was discussing, if you want to go ahead with the stubbed implementation, we can put a branching statement here. So if it is stubbed implementation, use one class, concrete class. If it is else, you can use another one. So there are a lot of other ways, but this is at least the simplest way to achieve that. So let's do this real quick. And woo. So let's see controllers. Okay, so this controllers, okay, I'm sorry, it's my mistake. I didn't fix this controller piece. Here also we need to change a couple of things. Let's come to this weather forecast, and the model which we have moved it to the core. So this model should come from the core. Okay, and let me come back over here. So again, this model, it will come from entities core, and now this guy should depend on iProfessors BLL. So let's fix this interface, and let's tell that okay. So I think that should wait. Now if you see this, the professors controller is depending on iProfessors SQL BLL. So that we are specifying in the startup.cs. So whatever you load it here, that gets stubbed in. So let's assume you're loading one out of two files. So what, based on the condition, whatever the implementation, whether it is a stubbed implementation or a prod implementation, that gets injected here. Okay. So now let's go back to this processes, and then we'll add it over here. So here also, whatever we load it, that implementation will get consumed over here. So let me check that there are no unused usings. There are no unused usings. Okay, cool. And here also you can see that we are using the DB context, which is here, which we have loaded again in the startup here. Okay, so that should be, let's do a build. Let's give it a minute. I'll have a glass of water in between. Perfect. So everything is getting loaded, and let's do one round of testing. I'll put a debug over here and here. And in controller. So this we discussed in the previous session, but let's do a quick recap. So controller depends upon business logic layer, which depends upon the data access layer, which depends upon the DB context, which is inside the persistence. So first it comes here, and then it finds that it needs the professor's BLL, so it comes here. Then it finds that it needs the professor DAL, then it comes over here, and then it finds that it needs the DB context, it comes here. It creates this instance and assign it over here. It injects, and then once this object got created, it injects here. Once this is done, it comes and injects here. Okay, and that one piece. And the other piece is, let's see the dependencies. The only thing is, this time instead of the concrete implementation, we are going it with the interface, not on the concrete implementation. So let's come and start with this. So you can see this. So there are 79. I think we have seen that in the previous session, but I would like to take one more minute. So some of the iLogger and other things which are getting injected, that we don't see here because these are only application dependencies. So those are built-in dependencies which comes out of the box. So it was 79. Then we had controller, Swagger, and then DB context, and we had our data dependencies. So now it is 185. So just expand this, and you can see that. So you can see this DB context, and see this time we are depending on the professor's BAL, iProfessor's BAL. So it is telling that if someone asks for iProfessor, give him a professor BLL. So here you can see that at the bottom, the tooltip, right? So that's it. We have seen the service container, and now let's see that how the dependencies are getting resolved. So let me come back and hit this. So as we have seen that first thing, it is coming to the DB context, it creates this and then injects that here in this DB context, and then that fully baked SQL DL got injected in the Professor's BLL, and the DAL has got the DB context dependencies. So you can see that entire chain of dependencies getting resolved. And now if you see that the Professor's BAL has been properly injected, and Professor's BAL has got dependency on DAL that got injected, and DAL has got dependency on the DB context. So you can see this entire chain of dependencies got resolved. So then it comes to the main method, it goes and hits it, and you can see this is returning the content. Okay, so that's it. We are pretty much done from the DB context, but there is one small change. So we'll do that. We'll do that in a moment. Let me get into this and bring in the course piece. Whatever we need to add the course piece, let's go get that course piece, because uh, we will be doing the integration. So we need this course. If not, when we try to do the integration with the Blazor WASM, this will not work. So let's spend 1 minute time and fix this startup class. So let me come in here and add these two entries and remove this entry over here. Okay, so we added that. That's the first piece. And the second piece is, I mean, this is only for our demo purpose. We are doing like this, but we should be extra careful what kind of endpoints and FQDMs you need to allow. You need to be extra careful in selecting that. So I'm allowing any origin, any method, any header, but that will be 100% careful decision. Speak to the infrastructure architect and the solution architect to find out what is the best thing to do, which endpoints we should allow and other things. That's a different discussion at all. So for now, so these are the three pieces we need to do. First thing is the policy name. I'm calling it as allow all, and then we are telling that allow all origins, all any method and any headers, and then we are using the course. So I think that's it. We are pretty much done. So now what we will do is we'll start creating the Blazor WASM. So we'll spend 1 minute of time, and we'll see the documentation over here, right? So let's go to this Microsoft documentation. I really love this documentation a lot. Now one simple difference, we'll see two images, and that should give. So this Blazor comes in two flavors. One is this Blazor WASM, WebAssembly. WASM is just a technical jargon. It's WebAssembly. One other one is Blazor Server, and Blazor Server is entire code gets executed on the server side, and only the markup is sent, and there is a Signalr in between these two guys. And if you see the Blazor WASM, here in this Blazor WASM, what happens is all the DLLs, Razor components, and the .NET DLLs, including the WebAssembly, everything will get downloaded at the browser side. Which, if you see this, here is the browser, but entire code executed at the server side, and only the markup gets pushed to the browser. But whereas in this Blazor WASM, all the Razor components, .NET components, WebAssembly, everything will get pushed to the browser, and then the WebAssembly executes this, and all the interaction happens here within the browser. It's like single page application until unless you invoke a endpoint to bring some content. Only at that time the control will go out of the browser to some server, get the content and flush it. Okay, except that everything will be here. Okay, so let's start building this. Okay, so I'm calling this as college Blazor WASM. I am creating a new project, and that is Blazor app. Okay, we create it, and here we select this Blazor server app, Blazor WebAssembly, and it is .NET 5 framework and configure HTTPS. So you're not selecting anything ASP.NET Core hosted or progressive web app. It's simple. .NET 5, Blazor WebAssembly, configure HTTPS. That's it. So you just click on create, let it create. So we'll come in here and ensure that we are not using the same ports. So here we have 5000 and 5001. Let's go to the Blazor WASM and let's check that what are the ports. It is also using the same ports. So let's go and modify this as a 5003 and this as 5002. So the web API is working on 5001 and the Blazor WASM is working on the 5002. Okay. And next 2 minutes is very crucial, folks. What we will do is we'll execute this Blazor WASM for the first time. And whatever we are going to see, this happens only once in lifetime. That means whatever the assemblies we refer, all as we discussed in this image, the Razor components, .NET assemblies, and the WebAssembly. All these things will get downloaded onto our browser. So this gets downloaded only for one time. And then until unless you create the new project. Okay. So this gets downloaded only for one time. Let's assume now we are using 10 .NET libraries. So 10 .NET libraries will get downloaded. And then we might bump up the version of one of the assembly. Only that library will get downloaded in future. Or we add more assemblies. Only those different assemblies will get downloaded. So just focus on this piece. I am going to execute it. So I should be extra cautious. If I miss, then gone. We need to create a new project to see that. I should be extra careful. Wait. Okay, it is starting. Okay. There's a browser. Okay, Control Shift I. I did that. So let me undock this so that we can see two things side by side. So you can see that. So it's still loading. Okay, now this entire application has loaded. First, let's see this here. So you can see here, so a lot of .NET libraries are getting downloaded. Okay, Blazor WASM and .NET 5.2 JS and a lot of .NET DLLs. Okay, and scroll down to the bottom, you see that .NET WASM. So these everything gets downloaded. As I was mentioning, this happens only for the first time. That's the reason you can see that a little bit of the size as well as the number of seconds it took to download all these things. Okay, And then if I come back over here and let me preserve the logs, I preserve the logs. And if I come in here, this is the last one. Okay, let me clear it off. Even though I preserve the logs, let me clear it off. Now I come in here, right mouse click, empty cache and hard reload. I did that. Now you see this. None of those DLLs, .NET DLLs are getting downloaded except the things which it needs, like the CSS files or something which it needs outside those Razor components and .NET DLLs. These things are coming in. We didn't see that .NET WASM, we saw that previously, and WASM 5.x that was also showing, which is not showing here, right? So that's a critical piece. Now, anytime, let's see this. Let me close this, and again I'll execute it, and then let's be real quick. Okay, I do a Control Shift I. So developer tools. Let's wait that. So that's coming in. So only see this. Only these files are getting downloaded. This is the same thing which we have seen previously, and I do right mouse click this one, and again, even though I did it, it's bringing in the same localhost and the bootstrap min app css. Only these files are coming in. Okay, so that's pretty cool. So we understood that this picture. Now we can correlate this picture. What is happening? So it is getting in all the Razor components, .NET assemblies, as well as the web assemblies. It is bringing in everything to the client browser. So I can see that. I mean, we'll dig deeper. We'll do CRUD operations as and when we progress number of sessions. This is session 2 of 15, so we have a lot of sessions to go. We'll add more and more functionalities. As I was mentioning, we'll introduce one concept, and in future episodes we'll come back and we'll add more to that, right? So that's it. So let's start building this one. So we'll see here one important piece, the HTTP client that has been injected. So anywhere we want that HTTP client, we can go ahead and use it. So that's one piece. And another important piece is we will come here. This is the main layout, where you have this side nav bar, and you have the top nav bar and the content. So these are the three different pieces. So let's correlate. Let's start it again, and then we'll correlate with each and every piece, like what those individual pieces are. We'll see that. And there is something known as imports. So these are the imports which will come, and let's see this. Okay, so if you see this, this is the side nav bar, which is there here in this main layout. That's a side nav bar. If you see this nav menu, that's another Razor component which is over here, side nav bar. Okay, and that's the top nav bar. We'll see that in the main layout. That's the top row, and this is the body. So that comes in here. So by default, when you go to this counter, you see this slash counter is here, and reserve logs is there, and I come in slash fetch. So that's a endpoint. So you can see this when we are doing fetch, that's when it made some network call. I come to counter, it didn't do any network call. I click this button any number of times, none of this network calls are happening. Okay, so as we were discussing that, so entire code is getting downloaded onto this browser, and everything we work inside this browser itself. So until unless you make an call to the server side or an API, so there'll not be anything here. See this again. If I go to home, it's not doing, and I come to counter, it's nothing is happening. When I go to fetch data, so that's when it goes and invokes the component. So we can come back over here and see that piece. And you can see this, there are three different pages. So let's see the first page, index page. So if you come to this index page, you can see that that's an index page. So if you go to this is a route at the rate page in this index razor component, it says route. So when you go to the default route, Blazor knows that it has to load this component index.js. Now when I come to this counter, so it is slash counter. So I come to this counter razor component. You see this slash razor. So that means that's an endpoint. And when I go to fetch data, it is slash fetch data. So you can see this slash fetch data. And one more thing is, as you have seen that we are having this, as we said, that the HTTP is by default, it gets injected. We have seen that in the program.cs. And apart from that, what do you see here is in this each of these razor component, you have the markup as well as the C# code. We have mixed both. So both we have the markup as well as the C# code in one file. So if someone who have worked in ASP.NET Web Forms, so in that ASP.NET Web Forms, what happens is you will have ASPX page where you have the HTML markup and ASPX sample. Let's assume that sample.aspx page is a web form, and its corresponding code behind file will be sample.aspx.cs. So that's where you'll write the C# code, and all the markup you will write it in the ASPX page. So we are not stuck with this model. We are free to go ahead and write in that model also. So let's see that. I've given this files in the starter files. Okay, I've given it in the starter files. So let's go and do this fetch. Let me copy this. Let me come back over here in the Blazor WASM. Inside this pages, I'm dropping this. So I'm replacing it. So let's come back over here and you see this. If you see the razor component, it is pretty much the same. It's not having anything else except that I did little bit of beautification. There's not much difference. Only thing is the same endpoint is there, the same markup is there, but the only thing is you're not seeing anything related to the C#. That we have moved it to the CS file, which will have the same file name, and it should be a partial class, and where we have moved our entire code into this one. So let's see that whether this works or not. Ooh. Let's compile this. Okay, so let's wait. Okay, so fetch data. You can see here. I go and click on this fetch data. So the fetch data, it is hitting this backend. I mean the code behind, or the kind of the table. Okay, so let's do a little bit of facelift to this application. So what does that mean? A little bit of facelift is we'll have given the entire thing as part of this file. starter files. So first thing what we do is we'll go to this, we'll go and grab this CSS file. Just give me a moment. Let me see that this is service URL 5001. Let me grab these two, nice, and go to this Blazor WASM, our source, and get into the ww root and drop it over here, and then take this app CSS and move to this one, existing one. So what is there in this app CSS is just added some kind of branding or the colors, nothing new, like what should be the color of top nav bar, or what should be the color of the side nav bar, what should be like those kind of little bit of branding, nothing fancy. So, okay. And the next thing what we have to do is we have to go to this shared, and we'll select this main layout and this nav bar. Let's bring those two things over here in the shade. So you've seen this main layout is the layout which decides that where the side nav bar should be there, and the top band, and the body content. Okay, let's come back over here and quickly give a glance to this, into this main layout. So one thing is here this make dark, that new style I've added, so that it makes this band uh, of the same color instead of having two different colors. You see the side nav band at the top, there's one color, and the rest of the top nav bar is another color. So just to have a same shade across the top nav band. And another thing is I have added one more menu. Thus we're calling it as um, professors from web API. Okay, so let's see, let's build this guy. Let's do a clean, and let's build, and let's see, did it impact the visual look and feel? Sometimes it doesn't. Even if it is not making, let's go ahead and start integrating with the web API. Let's I open the command prompt and I go to the D colon. I'm gonna keep this right. So let me go to this one and web API. I'm just keeping it aside so that I can free up. I can focus on the Blazor WASM itself. Chalo, let's start this Blazor WASM, and let's wait. Sometimes it flashes, sometimes it doesn't, but we are fine. Now you see this, just a branding, little bit of look and feel. So you can see this, it's over here, and let's go to the fetch data. So this one, the same shades and the same shade of this title. It's a little bit of this one. It doesn't exist. We don't have this page. So sorry, there is nothing at this address. So you can see that component is this guy. Oh yeah, see this? Sorry, there's nothing at this. So you can see this router. Here is the router, and based on that, which endpoint we go, it shows that piece over here. And if that endpoint is, see this, if I show the fetch data, so that means it properly routes it from here. And if I come to professors, which doesn't exist, and you can see that sorry, there is nothing at this address. This is what is coming in from here. So that's another piece of things which we have learned it. And now what we will do is we'll do the API integration. So I will close this, and let's go to the starter files. It will be in this documentation, starter files. And inside this pages, let's bring in processes from web API. I'm bringing in that and dropping that into the pages. So again, we created in the model in the sense we have separated the markup in the razor component and the code behind here in the C# code. So as you can see this on initialized async, this is one of the lifecycle method which gets executed, and the professors we are accessing it from the core library. So we need to bring in this project reference. You can see over here. So once bring in that, everything should get resolved. So right. So let's go. Let's start this. Let me do one small change. Let me come in here and just do this little careful, folks, because I don't want you guys to spit something in the debug console. Okay, anyways, I'm going to execute it in the release mode. Let it start. Sometimes what it does is it spits the EF core commands also. You should be extra careful when, I mean, just for the debugging purpose, you can use those things, but you need to be extra careful when we are spitting it anything out else. Okay. So now let's come back and let me close everything. Open and start this. And let's see over here. So see this, there was change in our WebAssembly, and we have seen that we have added dependency on the .NET Core. This is what we spoke previously. So initially when you execute for the first time, it brings in all the libraries. And another thing what we discussed is any new libraries we add it, or any libraries which got either updated, upgraded, or downgraded, or a modification in that library. So you can see that the college core, this was the new library which we have added, so that got downloaded, and our existing Blazor razor component, that got updated because we added new components in it. So you can see this razor components and .NET assembly. So this is coming as part of the that new modifications we did to the existing project, right? So all is well. So let's see, come in here and click. So nothing is happening. So let me close this and come back over here, right mouse click, empty cache hard reload. You can see that now this .NET Core is not coming in. And let me go to the fetch data. So you can see that it is coming over here. Now I did invoke this. An unhandled error has occurred. That's because of the port number. The port number on which it is running is 5001, and I assume I used 5002 or something. Let me stop this. Come back to this guy. Yes, I have used wrong port. Okay. So let me stop this again. And let me start this. You can see that. And let me run this one. Okay. So let's do Control Shift I and go to this fetch data. So you see that. and professors, you can see has made a call and it bought all this content. You can come in here and see this. The all the details are here. So anytime you go out, so now I'm bringing in this weather forecast, and now there will not be any calls after that. And now I'm coming to Professor's Web API. It's coming in. So that's it. So this is the kind of thing which I wanted to show. So what is next? What is next session in third week in Feb 20? We have the session 3 for this. So what are we going to do in the third session is we will see how easy it will be to add how easy it will be to add a new method. So at this point of time, if you see that our controller has got a single method, that is get all professors. Okay, now we will add get professor by id. We are going to add this method, so we will see the advantage of we moving the code, related code, to its respective libraries. So how easy for us or any new developer coming into our team, it will be pretty much easy for him to expose, because we have a defined rules. We set this rules. Okay, you have to add a method inside the interface, implement in the DAL and business layer. That's it. Consume it in the controller layer. And the next thing is we will go ahead and add a new page in our Blazor WASM project, where you have get all professors, and click on details. It should take us to a professors detail page. So that is one thing which you're going to do. And apart from that, what we will do is the same two actions, whatever we were able to do it in this Blazor WASM, we will do it in a Angular 11 application also. The same action, get all professors, both two SPA applications. One is Blazor WASM, one is Angular, and we go and hit these two endpoints. Okay, so I will check in the code, and the entire code, as I was mentioning, will be in this repository for this. And that's it from my side. That's it from my side. So if you guys have uh, any queries, oh, I'm really sorry, I didn't thanks, Prem. um, uh, I didn't I didn't show that piece. Let me quickly do that. uh, it's my bad. I'm really sorry for that. It was there in my plan. So let's do that real quick. So here in this web API, at this point of time, if you see this, the connection string is here. So we don't want to use this connection string. So what we can do is we have to come to this web API project, right mouse click on that, and click on manage user settings. Okay, once you click on this manage user settings, so that will create a new secrets.json. If you see that, that doesn't belong, that file is not part of our solution. This is coming from C users. Okay, so that is one thing. And another thing is, let me open the containing folder. And another important point to notice over here is it will add a GUID. It will add a GUID, because I already uh, have created. So what I am doing is I am using, let me use this GUID instead of the newly created, because how many times demos we will show. I can use the same one. So after that, when you want to go and verify that, again do the same thing. Right mouse click on the project and click on manage user secrets. It will come and show this one. So now what we can do is we can go to this app settings and remove this connection string and mention that your connection string. Okay, so now let's come back to this startup.cs, and let's put a debugger over here, and let's come and see that. I need to start this web API also in a as other instance, so that because we are sure that we didn't add any connection string in the app settings. So app settings does not have any connection string. We have the connection string, but that too in the secrets file. So now if you come and see this connection string, what we expect is we expect that it should show this your connection string. But for our surprise, it is nicely going and getting this information from the user secret file, which doesn't belong to our solution. So it is bringing in. So we'll come back and we will chase that in a moment. So that's there. So this is our Blazor WASM. Now let me come back to this controller, Professor's controller. Let me place this over here and then go and click on Professor's Web API, and it should come and hit this debugger over here. So that means all those 8 professors, we are perfectly going and bringing in that content and it gets displayed over here. Now someone can ask this question. So how does this IDE or this entire framework, how does it know that it should go and get the from the settings.json? So you can see this. Here is one int. We said that user secret ID. And another thing is, if you mouse over on this configure service and then just go and click on this configure service, go to the definition. Okay, hold on. Why it is not showing up? Okay, so okay, I'm sorry. I was there at the wrong place. I was there at the wrong place. I'm sorry. My bad. It's my bad. So if you see this, when you create default builder, so what all the things it is doing, you can see this. It loads this one, app settings, or load app Microsoft extension configuration, configuration from user secrets. So this magic happens here when you create the create default builder. That's where the magic happens. So I'm sorry, I was mouse over doing a mouse over on the other place. Actually, when you do a mouse over here, so you can see this. So what it does is it goes and gets the app settings or app settings and environment. If you see this, if you're running in development, it is app settings, not development. If you have some specific settings for a stage or test or different environments, you can have that. But this has got a capability to load that JSONs also, and also the user secrets. You can see that even user secrets get loaded. Okay, so thanks for asking that query. Who asked that? It was okay. Prem, thanks, Prem. Yeah, Dolly. How is the fetch data and fetch razor are linked? So as I was mentioning in the web forms also, the files will be with the same names. You have the same name and partial class. So if you don't have the two different files, but still what happen is internally it creates, if you see that index.razor, it creates the index.cs file, and that cs file will have the class name for this index, then that to be the partial class. So that is the reason, if we come here and to prove that, if we come here, go to this place, and the fetch data, if I don't mark this as a partial class, if I don't mark this as a partial class and go ahead and build it, so you see that it already started shouting at us, saying that missing partial modifier on the declaration type. Another partial declaration of this type exists. So that means it already creates another partial class. So that's how it binds. So it should have the same file name. If you see this, fetch data.razor and fetch data.cs. So that's how it creates. When you do a razor page, it creates a corresponding partial class. So You want to override that, you create a new C sharp, you create a C sharp file with the same name, and then make it a partial. So then it combines these two. Okay. So thanks. And any other queries? My logic, I need to make API call between in between database calls. In which layer the API call should be presented? So Prem, what will happen is, hey Steve, welcome. Uh, you're on mute, Steve.
Hey.
Hey. Hey. So I was just going through the Q&A, Steve, and you can also pitch in anytime you want to. So the at what time you want to make the API calls, Prem, that depends upon the architecture what you're using. So some people will use this clean architecture or onion architecture. Some people use this uh, classic three layer architecture. It depends upon your architecture. Some people different layers. So if you see this in our solution, whatever we built a business logic layer, and then you have a data access layer, and you have a controller layer first, then business logic layer, data access layer, which goes and talks to the DB context. So what we have defined is controller layer is not jumping in. It's not coming and directly talking to the data access layer. So we have delegated that to the business logic layer. So the immediate layer will talk. And if you see, some people will go ahead with the repositories. And on top of repositories, how are you using it? Are you wrapping or adding a new layer, business logic layer, which is talking? So the controller talks to the business logic layer, which talks to the repository. Or you're giving access to the controller to talk to the repositories. So different uh, architecture, whatever you select. So based on that, you have to do it. Anything to add from your side, Steve, on this? You're still
Yeah,
muted.
that was the question about who talks to the database. Basically, when do you call an API?
Right. Yeah.
And the way I look at it is all of my projects now have the same organization, which is funny to say that you could build basically anything with the same exact patterns, but it is true. And what I like to do is I do like to do that. The API calls the business layer, but the business layer controls what's going on. And if you look at it, it's like the domain part of it. And the domain can call an API, a database, and another API and another database. It can call those things in succession that it needs to call to achieve the business functionality you're trying to achieve. So if I'm trying to, say, book a movie, right, and I have to call the movie or call an API at a movie theater to find out the movie's there, and then save it to a database, well, then I do those 1, 2, 3 things in my manager, in my data access layer, or in my business layer. And so I've been using that same pattern for pretty much everything, and it works. I've built huge systems, and it just makes life very easy. I have some YouTube videos that talk about this kind of domain pattern, and it's been very useful, and it's really kind of straightened all that out for me. I don't even worry about where things go anymore. I know exactly how I want my solutions structured, and they work for every business problem that I've gotten.
Thanks. So one more query was, what is IEnumerable? So you want to take it? So IEnumerable is a collection, Prem. So like a list. So, and another question.
Actually, it's not a list, right? It's just the query to get to the
Queries.
list. It's
Query to
actually an abstraction over the list, and you can append it, which is super cool because you can actually create an IEnumerable that says, "Hey, I need in this," and it could be on a list of objects. It could be on any sort of different types of things, like data rows if you're using like the old stuff from 2001. And what it says is, "This is how I want you to get those things." But that's it. It doesn't actually do it. And then you can append to it and build on it. And then eventually you'll call something like toList, and then the enumerable kicks in and it actually does it. So it's like a deferred way to look at a list of objects, which is pretty
list,
cool. And you can pass it around, which is really neat.
True, yeah. To list and to array, we call it on top of this IEnumerable.
Yeah.
So that's what it's a collection of items, like as Steve was mentioning, collection of objects or collection of strings or anything.
That's why if you're debugging it, it says click on here to execute the enumerable, right? If you're debugging an IEnumerable, you have to click on it to see what's in it. It won't
Right.
just do it.
Yeah. So different between models and entities. So this question again was asked by Prem. So generally, Prem, what we do is we take this entity classes and that we use it in the data access layer or very close to the data store, and that will be one-on-one mapping with the fields inside the database. And then when you are spitting it out, we don't spit this entity, we transform the content from the entity to the data transfer object and send this data transfer object. There are multiple things, like if you have a date of birth and we don't want that date of birth to go out, but we want the user's age to go out, so that is one of the use case. Another use case is you have the first name and the last name or the middle name, whatever the name. So, and you want to split only the full name. So we concatenate all these things. We don't, and we send this one. So that's one of the use. Anything to add on top of this, Steve?
Well, I would say that that is a very specific thing to the person who's doing the development, I guess
Right.
is what I'll say.
Right.
I personally don't believe in that philosophy. So I
Okay.
do it a different way. I get it from the database and I go directly into my business object because I am not a big fan of a lot of layers. The layers of abstraction seem to help you out, but then they can cause a lot of extra work, and you really need to think if you want it, if you need it, right? I mean, if I'm doing microservices and it's not that complicated, well, then I'm just going to grab the data and do what I need to do. And what's my downside, right? You have to look at what the downside might be to something like that. So I guess it just depends. Lately, I've been I get it from the database. I don't use entities. I don't use entity framework. I actually kind of
Hey, you're
like
not
I build systems for like $18 billion companies, and it's got to go boom fast. I can't have any extra memory lying around, so I go from a data reader directly to a C# object, and then I do my work
Hey,
because
you're
I
not
don't want to. You know what I mean? I don't want the
I
extra
understand.
memory. I
I
don't pay. I
understand.
don't want to pay for that.
Okay, so hey guys, we'll take up some of the questions after Steve's session. Let me introduce our next speaker, Steven Swing. He's our solutions director. He operates from US, and he was very kind enough to talk. And I really appreciate and thank you so much, Steve. Could you please share your screen and let's see? Uh, I'm able to see. Then I will go out of the stream so that it will be your picture and your screen. Guys, we will take up the rest of the queries once Steve completes his session. So I don't want Steve. It's all yours, Steve. I'm going out. You can carry on.
Okay. How do I put a link in the chat?
Oh, you can put it if you see in the StreamYard. There is a right side. There is a yeah. There is a chat. There will be comments and there will be private chat. You should drop it in the comments.
Oh, I don't see where to do that.
Okay. Give me. I'm typing it here. Did you see anything ping on the right
No, I
side?
see the chat. I see the chat, but I don't
Uh,
see. I don't see where to put it in. That's okay. I don't need to do that. All right, let's get started. Let's
oh,
see here.
I'll give. Did you see a private chat message,
Yeah,
Steve?
I see it there.
Okay,
Yeah.
so I'm sending in one more piece of information. This is the YouTube one.
Oh,
Okay,
that's where the
so
chat is.
yeah, yes, right. Go to that
Okay.
YouTube and you can drop the URLs whatever you want to there
Got it.
in that.
Got it.
Thank you, sir. So I'm dropping out. I mean, I'll come out of the stream. So thanks.
Okay.
Just give me a shout. I'll come back.
Yep. Okie dokie. Good evening, everybody. It's 6 a.m. here, so it's pretty early for me. And but I wake up early anyway. I have a couple kids and a couple dogs, so I've been awake for a long time. I've been an engineer with AIS for 17 years, and I do mostly back-end systems. So my current job is with Geico, which is an $18 billion company, and I built their entire billing system. So I was the architect that pretty much tried to organize the whole thing and get it going. That system had, 7 applications, 38 components that we deployed. I was trying to go for the microservices architecture, but there's organizational resistance. And so when I say I'm a microservices and REST fan, I really am, but I can't seem to get an organization to really buy in fully to either one of them. So you have to kind of pick and choose what you can get done. So that's kind of why I'm interested in this topic. And we're going to talk about API management today. So this is Azure API Management. And if you've used it, let me know in the comments. I'm just curious, anybody that's used it before or have heard of it or interested in it, just put a chat. So I have the chat up here on the left-hand side, so I can see what people are saying, and I will stop and answer questions. So if you have questions, just let me know. I'd be definitely happy to answer it. And if you want to interrupt me, Swami, that's fine too. So today we'll talk about the use cases for API management. And then we'll do a tour around API management in Azure. And then we'll talk about some of the components that make it up. And then we'll just do demos and kind of poke around on it. So I have, I guess, about 52 minutes to kind of give you a sense for what it is and when you would use it. And I think that's probably the hardest part of this type of technology, because it's kind of like magic a little bit until someone demystifies it. So that's my goal today, is really to talk about it, demystify it, let you know where it's going to sit in, let you know what you should do with it, what you can't do with it. We'll talk about DevOps and how you can deploy it and how you can change it and maintain it. So when you get done with this today, with your current job or future jobs, you may say, hey, this is the problem that tool can solve in Azure, and offer it up as something that you can bring to the table with the people that you're working with. Okay, so this is a diagram we're going to spend a bit of time on, just to talk about what you can do with API management. And I really, really like API management. It offers a lot of things for me, and this gateway service is probably the #1 thing that I can think about. And so there's a lot going on in this diagram. I just want to point out a couple of things. So when you put this here, it acts as a kind of like a gateway to your backend services. Okay, so that what you get is that it's almost like a reverse proxy. And a reverse proxy is going to give you, this is it in the middle, it's going to give you a lot of power and a lot of abstraction over these services here. So if you didn't have this here, each one of these systems would come directly into these microservices. And when you change those microservices, they would automatically change. So you don't have this kind of shim in the middle in order to absorb those types of changes. So by putting API management in the middle, it kind of decouples the front ends from the back ends, and it lets you route the traffic. So let's say I had this microservice here, but I wanted to retire it and put in a new one. Well, I can stand up the new one and then do a redirection here, and the front ends are never affected. So so it's a really good pattern to have when you have a microservices architecture, or any really any APIs at this point. It does content translation. So just about every company has a mainframe. I really think it's actually everybody I talk to has a mainframe, but we work with big financial companies, insurance companies, healthcare, you name it. They all have these legacy mainframes, and nobody wants to be on these mainframes. Well, mainframes were doing SOAP from 2001, and so they're kind of stuck on SOAP, and so they have these SOAP packages that they do, but nobody wants to use SOAP anymore, right? SOAP is messy and ugly, so you can use API management and stand up a JSON endpoint that systems can do, and they don't know any different that it's SOAP, and then do the translation and send it down to the mainframe. So you can abstract your microservices and your mainframe into one single kind of surface area for your entire enterprise through API management. Also, it can be your first line of defense. So what you can do, and I don't have it on this diagram, is I could have Active Directory here, right? And I could, that wasn't supposed to be a D. I could use OAuth, and then this would take care of the OAuth, right? So now I have my authorization in one place, and these microservices and the mainframe don't have to worry about that, right? This can do the OAuth, get the token, and send the token down into here so that they can do the authorization based on the roles that are within the token. So it's nice to have a central point there to do that. And then talking about security, I want to point out that I did do a couple things intentionally here. This is in a subnet, and this is in a subnet. The whole thing would be in its own VNet anyway, but they're in subnets, and the reason you do that is because I don't want these microservices and these APIs to be accessible anywhere, right? So I'm going to lock them down. The only thing that can get there is API management, and it has rules crossing these subnets in order to get in there. So I don't have to worry about my microservices being accessible anywhere else because there's only one place it can come from. It has to come from API management, and it has to come with the token that I'm going to get from Active Directory. And so I'm now secure. And now these APIs don't need to worry about security because I've handled security by locking it down at the network level and using API management as this kind of gateway into it. And so that's a big cross-cutting concern that you've now accomplished with this particular tool. So that's an amazing thing to do. Another thing you could do with it is that I might have another service over here, and I don't have it on the diagram. I might have Redis, right? Let's see, put a big R here, right? Redis. So I might have Redis there, right? And so I can have caching managed by my API management. And this is where I think a lot of organizations really have no idea whatsoever how to do caching. But most systems, right, they do caching up here, right? They'll have their UI cache it, or they'll cache it in the browser, or they'll have a web app here that caches it, and this web app actually goes to this thing here. So they'll have caching up at the UI layer. Well, that's the wrong place to do caching, and if you do caching that way, you're going to have issues because how do you know when you should invalidate the cache, right? You don't know. So the way that you do caching in a RESTful way is that these systems here send the cache headers, and they say, hey, you know what? This data I gave you, it is good for 1 hour or 2 hours. Or what they do is they say, hey, you know this data I gave you, here's an E tag. I want you to give me this E tag back, and if you give me the E tag back, I'll tell you if it's good or not. And you can control all of that through API management, and the intermediaries are what make REST powerful and what makes the internet work. And so you put this intermediary in between your API and the UIs to manage the caching for you. So it doesn't have to be managed either by the backend, but the backend does manage how long it lasts, and you have to kind of build up that E tag logic, and you have to send the cache headers so that it says what it is. And then the UIs just basically get the data. They don't need to worry about that. Isn't that a fantastic thing? I mean, how many people have added caching to their application and just been struggling with the fact that it goes bad and they don't know it? So here we have security. We have the fact that it controls, it decouples them. We have caching. Another thing you can do with this is metering. So if I had, let's say I was selling, let's say I was a movie theater and I had a lot of data that somebody needed, right? But you could only get to my data 5 times per day because that's what it is. Or let's say I want to sell you the data and it costs $5 a month for an unlimited subscription, and you can come in 50,000 times a month and get that data. Right? Can you imagine doing that in a microservice? Like, that would be a mess, right? It would take forever to build. You'd have to replicate it across these things. And it's really just not a concern of theirs. So API management lets you do metering and throttling and really control the API stuff that you have. And it also does monetization. So if you want to sell your data, you can do it there as well. So that's a really powerful thing that it can do. The one thing that I would recommend not doing is business logic, right? Do not put business logic in API management. Business logic does not belong in the middle, in a broker in the middle of a system like this, in my opinion. So so keep it out of there. So those are the kind of the main use cases for API management. I wanted to go into one of them a little bit more specifically, though. When this is the developer portal. So the developer portal is a big selling feature of this, and I think it could be useful pretty much anywhere. So even if you were doing it within an enterprise, or if you were doing it B2B, or selling it to the public, deploying your API and conveying what that API does to developers and to other people is very difficult to do. But this makes it very easy. So it uses Swagger to generate this UI, and you can generate the UI however you want to do. And it has this UI that's, I think it's called, it's like a, what's it called? A static site. What's that new static site? I forget the name of it, but it uses like current technology to build this UI that you can then use to see what the API is going to do. You can test the API. It's got a console. So it's a very a useful way to do it. Also, and I didn't talk about it, but there's an entire metrics part of API management, so that you can see who's using what and how they're using it. So that's an amazing thing too. But the developer portal is kind of a big deal that you kind of get for free almost with all the other things on there. So there's really a lot going on here with API management, and almost every single architecture I put together now has API management in it in some way, shape, or form. Like I need to have it there. It offers so much benefit, then we're good to go with it almost every single time. So let's see. I don't see any new comments. I don't know if I'm looking at the wrong screen though. Let me see. No, I don't see any. 6:17, so I don't see any. Okay, so
Yes, there are no new comments, Steve. I am keeping a watch. So what I do
okay,
is I
okay,
collect
cool.
all those thing in the notepad. So at the end, even in previous Renuka session, I collected 5. So that's how I am doing it. So if something comes up, I'll interrupt.
Okay, I see.
Thanks, sir.
So this is cool. So I can do the presentation there and see it over here. All right, cool. Now, all right. So we're going to talk. I'm going to go into demos, and we're going to play around with things. But I wanted to give you a quick kind of lay of the land of what we're working with here. So for me, CI/CD pipelines deployment is the #1 concern, and I just simply can't live on a project unless I can deploy things automatically. So that's what I have here. I have a way to deploy the API management, and you can see it here down at the bottom. You can see it down at the bottom here. So this is my API management, and what I have here is I have 2 solutions up here. This is #1 up here. This is my .NET Core API, and it has a package called Swashbuckler on there. So it's a NuGet package, and what the NuGet package does is it reflects against the API and produces a JSON file that contains the definition of the API. This is actually something that AIS built. Like I want to say 2011, we started with a web API. We worked with the team. We built the help pages. And then this is kind of an extension onto it. And they sucked that metadata that we built. And then instead of producing HTML, they produced a swashbuckle or Swagger document. So a very interesting package. And it's really grown, actually. I think it was outside of Microsoft, but now it's swashbuckle.asp.NET Core. I'm not actually using that because I've done this demo now for the past couple of years. So I actually looked at my code, and it's very old. So anyway, I have a .NET Core app, and then I have Azure DevOps with a pipeline, and it deploys to an app service. It could be anything. You could do this with containers in a function. You could do it with Kubernetes. It doesn't really make a difference. The thing is, the idea is that you have an API that produces Swashbuckle. Let's just take a quick look at what that API does, and it doesn't really do very much at all. It's very simple. So, and actually, it doesn't have a back end. So I don't have an example of all of that, but I play racquetball, and there's these ladder tournaments, and so I built this. I always go back to this ladder tournament thing, and so I have just a couple of. I have one controller called Players, and it has just a couple APIs. Here's a get that returns a list of players. There's that IEnumerable of players, and it returns just the 2 players. And then I have another one that returns a single player, and then I have a couple more standard APIs. So it's just the simplest API you could possibly build. I will say a couple things. I've added some comments to this, and because this is what Swagger will produce. So if I run this app, and I have to remember, if I run this app, I should be able to see this documentation. Let's see here. I remember what it is. There. So if I run this, there. So there's my JSON. That defines my API, right? And we'll use this later on. So then what I've done was that back to here, I have this simple API with this swashbuckle. I have it tied to Git, and then I deployed it to Azure App Services. So here we see the same thing, and now I'm in Azure, and I can go to my resource group, and I can go to my app service, and then I can pull up this. There's my URL to my API, and I can go ahead and pull that up, and it'll come up. And so this product actually brings up this. It actually brings up the UI. So the swashbuckle code has this UI, and so this is what it looks like. And you can actually test these things out. So if I come in here, I'll do a tryout. So it's really actually off of the point that see it actually did it return it? Anyway, so swashbuckle is great and it's super useful. I actually could take this URL. I can actually take this URL and put it into the swashbuckle UI. Swagger UI. So this one here has this live demo here. And so this is their pet store, right? This is not my site. This is their site, right? But if I come in here and I grab my URL, which is here, right? Copy this, and I go into their site and I put it in, and then I have to actually put the end part of it in here, though. I don't have it's not fully qualified yet. But I put that in there. Click explore. Now, so this site, this pet store Swagger, this demo site went to my Azure app service and pulled down the Swagger and showed it. So just a standard way of showing it. Okay. There's a reason why I'm getting to this. So there's my app service with my Swagger. Okay. And it produces a Swagger here. So what I have on the bottom of this is I have another project. This one here deploys Azure API Management. So the way that this looks is here, and this is what's called an ARM template project. And if you start up Visual Studio and you say project new ARM template, you get this. I didn't change hardly anything on here at all. Actually, this was one of the first ones that I ever did, as a matter of fact. But what it has in here is it has it has API management as a resource. And I think this is it. So this is my resource for API management. And what I have here is I have a PowerShell that deploys it, and then I have Visual Studio here, right here, and I have a YAML pipeline. If I go to my pipelines, actually I don't need to go to there because it's a YAML pipeline. I actually need to go to here. And so here I have this YAML pipeline that deploys this thing, right? So when I check it in, my API management gets deployed to Azure, actually, which is pretty cool. Now, I did set up a couple things in here that are interesting, I think. So let me back up and just say this. So we talked about the Azure Resource Group in Visual Studio. And then I showed you my pipeline that deploys it, and then it deploys it to API management in Azure. And then the way that we need to build APIs is interesting, and there's a lot of ways you could do it. So here I will go into API management. Now I'm back into Azure, and I'll go, I'll go into API management. So now I'm in API management. This is what you get out of the box. And here's your APIs down here. So I guess here's the URL for it as well. So here's my URL. Here's my APIs here, and you can come in here and look. And I have my ladder API right there. Okay, so it automatically creates itself. In fact, I was working on this yesterday, and I hadn't looked at this in a long time, but I had everything in source control. So I basically went to my source control and said deploy everything again, and this is what showed up because it's all configured to do that. I had to fix the service principals. They all went stale on me. So, but you can add another API, and these are the ways you can add APIs. Okay, so API management is really baked into everything in Azure. So if you're in Azure, you're probably gonna want to use API management because look, it's already tied to function apps. Here's app services or logic apps. So you can put all of these in here. This open API is the Swagger document, basically. But there's two other ways you can do it. And there's a WSDL, which is that nasty soap stuff. This is so gross. But anyway, this is not how I added the API, but you could. But we're not going to. I'll show you how I added it, and we'll go back to this diagram. What my API management does is it actually, during deployment, will hit my Azure app service and get the Swagger document and generate the UI for me, which is fantastic. I don't have to do anything. I just have to configure it to connect together, and we're good. We're good to go. And the way I did that was this right here. I set on my API. So here's my API, right? I set to use my Swagger document. So I have to deploy this first, right? My deployment process isn't that sophisticated, but it could be. I could say, hey, you know what? You need to deploy the API first, then you can deploy API management. You can see that there's this display name here. We can try to change it, and then it would change as I deploy things, but we'll maybe get to that later. So that's basically how the deployment works. I don't have a good diagram for it, but pretty much you could use PowerShell. You can use a REST API to Azure. You can do anything in Azure through an API, basically. And you can use an ARM template, and you can use Terraform. So you can use all of these different things to deploy API management. So it's a full-blown deployment. There aren't any things you can't do with a CI/CD pipeline. So there's no excuses for not automating everything. And automation will set you free anyway. So that's how it works basically with deployment. Any questions? I don't have the question thing up, but if you have a question, I can stop you. But I'm going to go into some demos now with the way it works. So so here we go to demo time. I will show you. Here is the way the API works. Okay, I can do a simple get, right? There's nothing really that fantastic about that, and it returns those two ones that we saw before, and so you see the URL, right? This goes directly to my app service. Okay, and then what I have here is I have this one here goes to my API instance instead. It does not go to the it does not go directly to the API. So if I hit this, then it should return back. This actually goes to a different API, but it did return back the single one that I had. But I want to show you one thing that you have to do in order to make this work. And this is my subscription key. Okay, so API management, I mean, you have to really think about management, right? You are going to manage your APIs, and they have what's called products that have to be enabled for you to do that. So if I come into here, I have these products, and there's two products right now, right? So you're you're going to do something with this API and provide it to somebody else. So the products are a good way to group your APIs. So I have this starter project, and I've added this API link here, right here. So otherwise it wouldn't show up. So if I get rid of that and I try to log into something, it won't be there, and I can't execute it. And then I have these subscriptions, and so here is where you can see the subscription keys. And so this is what you have to have. You have to take the subscription key for the product you want to use and put it over there. If I don't, then let's say I have the wrong one. Let's just do that. This access denied, invalid subscription key. So just to show you the kind of control you have over your APIs, and it's just so simple that that I can then get my subscription key and then put it back in, and we should be good to go. So tremendous amount of control over your APIs, and a very simple way to do it too. Another piece of control we talked about is metering and such. So let's take a look at our API here, and let's take a look at this one. No, it's this one here. So here I have this API. This one here is players / and then the ID. And here I have a rate limit, and we can hover over it, and it says calls 70, renewal period 10, and then it has a way to count. So it's going to count it by IP address. You can see, I'm looking right here. So this shows it here. And you can edit this right here, actually. So if I click on this, it'll bring it up. And so this is the way all of the policies work. And the policies have so many things you can do to it. And if I click on this, it'll show me all of the different things that I can add to it, right? So here's all my caching policies. Here's my access policies, and so on and so forth, even retry cores. So this is everything you need to know and do with APIs. I even had someone that was they were parsing a PDF file. They built a policy to parse a PDF file. I said, I thought it was a bad idea personally, but the fact that he could do it was pretty impressive, actually. I was like, okay. So here we have 70, and I think that 10 is 10 minutes, actually, but I'm not 100% sure. So it's 70, which is quite a bit, right? So this is, I'm going to go back to Postman. I'm going to hit this one a couple times. So it would be this API, right? It was players /1. So I can send this one, and I can keep sending it, and there's no real limit to it. Oh, there I hit it. I hit my limit. I'm not sure why. I thought it was 70, but anyway, so I hit my limit, and you can see that it says, hey, you need to wait 56 seconds again. And if I hit it again, it'll actually go down. See, 40 seconds. So so here you have your rate limits. Although I'm a little bit surprised I know I set it to 5 yesterday, but it does say 7 there. So I'm not sure why that worked the way it worked. But anyway, you have a lot of control over these particular policies. You can change the policy when it comes in, and you can change the policy when it goes out too. So imagine you were calling a mainframe. You would change it from JSON probably to SOAP, and then on the way out, change it from SOAP to JSON. So this is where you would do something like that. So those are the policies that you have. There is no limit to the number of calls. This limit is something that I put in, and it would be something that you would put in. API management can handle, it can handle as much as you can throw at it, basically. So yes, and the other thing in terms of microservices is that let me see if I can find it. So this is this pattern I showed you was the this is net. I showed you the gateway, but what you can do for microservices too is you can have multiple API you can have multiple APIs for each particular type of front end, and that's what's called the backend for front end pattern. This one here, and so I don't have a good demo of it, but you would have multiple gateways for each front end, and then you would control the kind of content that they would get each one of them. Or, microservices for me would extend into the UI anyway, and they would know what to get. So hopefully that answered your question. So the rate limit's basically up to you. The next thing I want to show you is kind of how this deployment thing works here. So let's see here. We can change some of the things about the API here. So this latter API is in the display name, and you can see it when we're in the API management. It's right here, actually. I think it's at the settings. Yeah. See, I think that's that's not it. I forget where it goes, but anyway, I can change all of these parameters. All of these here are in this document here, actually, and so is that rate limit. See this rate policy? It's right here, and so this rate says 70 here. But if I want to change it to something like 13, I can do that, and I can save it, right? And then it should change. And so I'm not going to push it yet because I want to change my API as well. So I'm going to go over to my Azure portal, and I want to take a quick look at the developer portal. Okay. So here is the developer portal, and it uses, I just forget the name. It's a static site technology that's pretty easy to use, and you can change all of this. So I'm in edit mode right now, which is why you see these plus signs here. I can change the background if I want to. I can change anything I want to about this. I think I can even, I can change the names, whatever you want to do. You can change anything on here, and it'll stick. But if I want to look at it from as an end consumer, I have to go to a new window with. This is it actually. I have to go to an incognito window, and so this is what it would look like if I wasn't logged in. So. Then I can look at the APIs here, and you see we get this pretty awesome portal. And this latter API shows up because it's in the kind of the free tier product. If I got rid of this as a product, it would go away. Actually, we can try to do that. Actually, I'll probably stay away from that. So I can go into the latter API, and you can see all my definitions. You can see kind of what it's going to return. And if we go here, you see these things here. So this says a list of players too, and and here we see some of these what it does basically, right? There's a ton of documentation here, and what I think is what has happened over the years, I think, is people try to do Word documents or whatever to document it, and basically they go stale almost immediately. So if they go stale immediately, where should you put your documentation? And my argument is that you should put the documentation literally in the API. So here is the API, right? Here are my response codes, and I can change this. I can change this one here to the 400 would be, it's 400, bad request, right? This is a bad request to the .NET learner house. Okay, so I'll save that, which checks it out, and then I'll go ahead and push it. So we'll go in here and so we'll go ahead and commit and push it. Right. So this is going to go up here, and if I go over to my Azure DevOps, which is here, you can see my pipelines should be running pretty soon. There it goes. So it's running now. It's deploying this change to Azure, and because I checked into my master branch and everything just goes directly there. So I don't know how long this takes. Maybe a couple minutes it takes. Let's see, 2 minutes. So this will take 2 minutes to go. But I've modified my API. We just have to wait 2 minutes for it to go and get there. So then I can deploy this as well. Now this deployment only takes 2 seconds actually, but that's not completely true. The first time you deploy API management, it takes, I want to say the first one, actually I have the record of it. The first one took quite a bit. So this is my API management. We can look at my pipeline. You can see when I deployed it the first time. Here's where I had some issues with security. It didn't work. But this one here, this one worked halfway, and you can see it took 33 minutes. So you don't deploy it. It doesn't recreate it every time. Now it only takes 1 minute because it's doing a difference. It's doing a differential, so it's not actually deploying the whole thing. But the first time takes forever. And just in case you were wondering, it's about $50 a month just to have it. Even if you don't include the number of times that we're calling it, the fact that you've spun up API management at all is $50. So, you just be mindful that, don't go in here and play around with it. And, unless you're, you have a way to pay for it, or you're using the free version of things. So, so we'll do that. And then, let's see here. What was else I was going to show you? Well, let's just wait for this. Any other questions? One. So Azure's going to take care of your your resilience here, and so you can actually go to Azure SLA API Management. This is what you're paying for, right? This is why we use Azure. They have these SLAs for all of these things, and so one of them. See this? It's what I mean. It's up there, right? It's what, 3 nines, I guess. What's 3 nines? That's like 15 minutes a year. Is that what that is? It's something like that. But you don't have to worry about that because that's here you go. Scaled across 2 or more regions, 99. That's 4 nines. That's not going to be down very often, basically. So you basically just leverage that. You're paying for it for a reason. That's what the cloud's for, is to kind of, so you don't have to deal with some of these resilience concerns. Those are all baked into what you're paying for. All right, so it worked in 2 minutes, right? So now I've made my change to my API, and I'm going to now check in the other one, this one here, my API management. Remember, we changed the rate limit to 13. And we can change. I don't remember where that display name comes in, but we won't worry about that. But anyway, we can see too that the API management did not pick up this change yet, right? If we go into the ladder API, we go into the design and we go into, was this one here? This is 400, right? It doesn't show, it's not going to show what we're looking for. Or if I'm in the developer portal, which is this one here, right, and I refresh, it's still not going to show it. So it's this one here, but it doesn't pick it up immediately. Like this is the 400, and it still says demo of dev change. So here we will check this in now, and then we will see if I did not break anything on my UI, which I probably did. So let's go ahead and change for user group. Commit and push. There it goes. Oh, what did I do wrong? Oh, you know what? I don't have the latest. Let me do that. It is not a demo unless you screw something up. All right, that wasn't so bad. So now, I don't know if I have this pipeline hooked up or not yet, so I have to take a look. It should be hooked up. Oh, there it is. There it's hooked up. Now we're just waiting for it to get picked up by an agent because I'm not using my own agents. I just use the agent pools. But it should only take about a minute to change, to do what we need to do. Remember, it's going to deploy this, it's going to deploy API management. It's going to do a difference of what it is, and it's going to go to my API and pull the Swagger document and then refresh basically everything that we have to refresh once it goes anyway. I don't think it's really working. There it is. That's it. That's it. It's done actually. So that was fast. So now when I come into the developer portal and I'll just go ahead and start from the beginning. The APIs, and I'll go into my ladder, and then I'll go into this one, and it was the 400, right? Uh-oh, didn't work. No, I don't think it was this one. It must have been this one. Yeah, it's this one here. See that? There we go. That's what I put in there. See, so now your documentation, look, it's just such a tight package, right? And you can do it in .NET Core. You can run it in a container, and you can have all your documentation baked into your code and automatically shown to your customers. The other thing is that and I don't have a good demo of it, but versioning is always a big problem with APIs. And there is a way to do versions of these APIs here. And you can, check the number of times that it changed. You can do version, you can have the API management route based on version as well. So there's a lot of different ways that you can set it up to handle all of the different cases that you have. And pretty much there's no, nothing you can't do with it. I think it's got a ton of things you can do to it. That's about all I had, and that's about 50 minutes. I was hoping I would get some questions. Didn't know if there was any more, but I'm more than happy to sit around and talk about API management.
There are few queries.
Okay.
Steve. So the first one, I think Prem asked this. Let me put it all these 5 queries inside the private chat so that you can get it at one stretch.
Okay.
So yeah, these are the 5 queries. You guys, please feel free to post any more queries. Okay, version dependency tracking across microservices. So this is the 7th one, Steve. This is from Sharath.
Yeah. Okay.
But these are 7.
So, we have a situation where how much latency does that add? You're getting latency in production with this configuration. Are you going through?
Oh, actually, Prem asked those first 2 questions. So what was Prem was telling us? Okay, the first question from Prem was that he was asking, we have a situation where a microservice needs to make a call with other microservice in the same VNet. We are currently going through API gateway for this API call. It adds latency.
Well, so, whoa, that's a good question. You know what? You should really ask yourself, should they be calling each other going across VNets through that pattern? Like, you know what I mean? Like, so for me, I don't believe in that. I don't believe that microservices should call each other. But, and they shouldn't, and certainly if you need low latency, you need to think about your security and your infrastructure architecture to reduce that. Remember I said earlier, I don't like layers. Well, that's what you've done. You've now taken something that's supposed to happen really, really fast and added 2 layers in the middle of it, a gateway and an API management. So for me, I don't personally believe in that philosophy. And I think you're probably going towards more of a microservices, like a mesh architecture. So I would question the infrastructure and configuration of that. So for example, if you were doing Kubernetes would manage all of that internally, right? You don't even have to put a fully qualified name. It knows how to go from one service to the next. So you don't have this kind of overhead in the middle of the whole thing, right? And in addition to that, once you're back there in the microservices area and they're talking to each other, is there a level of security that you can assume, right? You had to get back there in the first place. So I don't know. I don't know. I might question whether or not that's a good idea at all, to be honest.
Steve, Steve, this is what is my understanding. So we have a microservice A, and we have a microservice B.
Yeah.
Let's assume those two belong to the same VNet. That's what Prem is telling, and I'm assuming that these are all deployed in Azure. So we have A and B.
Yeah.
So,
This.
so everything is within the Azure. As far as we know, everything belongs to everything belongs in the same Azure. So it will be few milliseconds when we microservice one hits API management, and API management hits microservice two. So that latency will be in milliseconds, if I'm not wrong, until unless there is a heavy processing happening in microservice two. There should not be any notable latency when microservice 1 calls microservice 2 through the API gateway. Correct me if I'm understanding is
That's not a pattern I would do. That's what
okay.
I'm saying. You're doing something that I would say is a bad idea.
Okay.
That's me. Me as an architecture, I would say that this is not allowed to call this through HTTP. Period.
Okay.
Why do we need to do that? And so that's my philosophy of architecture, right? I just think that these microservices should be 100% autonomous. They should be able to get the work that they need to get done. They may have to call backend services, but I shouldn't need to call them. What happens if microservice 2 is down? Then microservice 1 is down. Well, that's not
Dependency.
good.
We are creating a dependency. Yeah.
So that's a bigger question. It's a good question, though. I mean, I think, and it's a philosophical thing. So if you were doing a service mesh, would you do it this way? I don't know a lot about service meshes, though, right?
Yeah. But one more thing is we can drop a message even if you want to do this kind of communication between microservice and microservice. We can drop a message in ESB or some kind of MQ.
That is my preferred method of communication. Is that asynchronous pub sub communication between the services?
Service, yeah. But this becomes like a request response. As you told exactly, you pointed out the key feature. Like one calls two and two is down for some reason. Boom. Now one
I don't
doesn't.
like the temporal coupling. That's what you've done. You've temporally coupled those two systems together. Now your resilience is lower, and your dependency chain is higher. And if you're going to do that, you need to at least admit that you're doing a service mesh. Hold on one second. I need to shut my door.
Okay. So that's frame because you're doing a request response. See, one is calling two. What if two calls three? So if three doesn't work, as Steve was mentioning, so one calls two is working, but two internally calls three, then one is not responding to your user. The best, I mean, one of the suggested ways, drop a message in some queue and let it pick it up. And this point I didn't understand. We do not want to go through API gateway for this API call. It works in production. I didn't understand, but how do we do this in development? Okay, if it is related to the first question, Prem, that's what as Steve and I were talking, it could be good that you drop a message in some queue and pick up. Steve, his question number 2.
Yeah, honestly, so you have to. What we do with API management. When we have an API management contract, and we've done a lot of them actually. The first thing I do is I get my infrastructure guy in here, right? And the infrastructure guy, VNet, joins it, and he makes all of the connectivity work the way we want it to work. And that goes to security too, right? So having it VNet join, having it, connectivity from on-prem over to here. Of course, RBAC is going to be a big deal in terms of who can manage what with API management. So there's, it's just like every other thing in every other service has RBAC tied to it and what you can do to it, and what people are allowed to do. So for example, if I'm the administrator, I can do basically anything here, but the developer should only have access to particular APIs, or the ability to update policies or something like that. So not everybody can add an API, or maybe you don't let anybody do any of those things, and you have to do it through source control, which is pretty much the way I think everything should be done anyway. So so you can definitely tweak out the access and who can do what and where, but pretty much every Azure resource has a kind of a management plane, which is the management of the resource itself, and kind of a data plane, which is the management of the data inside of it. And that's the way you should look at all the security in Azure. So,
Hey Steve, this guy Prem replied. He's telling that the microservice 2, which is being called from 1, it has got a ML model, and that was too heavy processing as we were discussing. The
oh,
community, yeah, that's the
so
reason they are seeing it.
yeah, I mean, look, if it's going to take a long time, then publish a message and go back and get the data later, or you could
Yeah.
pull it. I do a whole presentation on enterprise patterns, by the way. If you really want to, I have a whole doc. I just looked at it this morning. I wonder, here it is right here. So
We can do it on 20th February, Steve, if you are available. Third Saturday, third Saturday.
yeah, so it gets into this, right? So if you have a time problem, you need to pick your integration pattern differently than if you don't. You can't wait around for stuff.
Correct.
Okay.
They should have selected the messaging instead of request response.
Yeah, you have to go, so here's the thing is every application has HTTP. There's no doubt about it. You cannot build an application without it. Even if you're doing what you did your demo on is the GRDP RPC. So no matter what, you're doing something over HTTP. But I feel like 50% of every system I build is also asynchronous. 50%. So I might have an API that only publishes a message. So you call me, and all I do is I send a message off to do the work, and then I have a way to get back to you, and that's the Signalr. You did Signalr at the beginning. That's a fantastic way to do that. So you can actually tie Signalr to a service bus, and then tell the person looking at their screen, "Hey, your work is done." That's a fantastic way to build this asynchronous pattern,
Wow.
right?
Right. So how do we secure API? That's the third query.
Yeah, so we talked about RBAC, and I talked about that a little bit just a second ago in terms of, you know, assigning what people can do, and it has an entire security model. So you'll be securing who can change things with API management from a management plane, and then I believe there's ways to secure who can add and remove and modify different APIs. But like I said, I build my APIs from the Swagger document, so I actually don't need to secure that because I can let whoever is building the microservice deploy their microservice, and then they can tell me, hey, I need you to let it update, and then have it go. So
So the
actually,
query 4 is she's asking about app service and APIM.
sure. So I have an app service here. So here's my app service right here. An app service is basically going to host my my application. So this is where my .NET API code goes. So that's this code here, right? Right, your controller and your API and all this stuff. That's where that app service goes. This provides the API, right? And then this API management, right? Here's my API. Here's my API management right there. That's API management. And then this is my app service. So my app service is it literally does the work of the API, and this sits in front of it. So if I was back on my diagram, this is the app service here. And then in blue, obviously this is my management here. Hopefully that makes sense. One provides the API and one provides a layer on top of it that kind of manages it. Right?
Yep.
And
For
then,
each that you answered, I think so. About the rate limit, he was asking about.
you can look at the cost. I don't know how many of you folks have done this before. It's kind of interesting. You come in here and you build the calculator, management. So here's API management. you can see it's $48 a month. Just turn it on. And then I think there's the support. There was a way to see how many API calls. It was pretty cheap though. Oh, maybe it's not there because I don't have this. So if I do premium, I thought there was a way to see how many calls you make. You can see though, it's not cheap. $3,000 a month for the premium. But it must not be per call. I thought it was per call. I guess not. Anyway, yep. So I thought it was per call. You paid per call, but it doesn't look like that's the case anymore because I don't see that. Okay, those are the costs. Let's see. Version dependency tracking across microservices. It does do that, but I don't have a good answer for you. There is a way to version it. There is a way to do it. You can, I think, stage an API change and then deploy it and have it take effect, and then you can switch it back and forth. But I haven't played that with that piece of things. So come into API management, APIs. Look at this one here. There is a way to do it, and I don't remember what it is. So no, I don't remember. But it does give you a lot of flexibility, and I think that actually the routing would be one of them. So the way I would do versioning is I would first version your persistence store, right? That's the hardest one to do, so you do it first. So if you're using like SQL and you needed a new change, you would do it on the database first and let your API be backward compatible to your database. Then I would stand up a new version of the API that can stand alongside of my current version that uses the now version 2 of the database. And then I can do kind of an A/B testing or canary testing against that, or feature flag it so I can have my API, my UI picking that new API based on percentages or based on location within a geographic area. And then I can have my API management eventually switch over to using the new API. But versioning is a real tricky thing. I actually don't believe in it, to be honest with you. I prefer to evolve my API anyway. And a lot of enterprises refuse to do that, but then they refuse to version their APIs anyway. So like at Geico, we have never versioned our APIs despite it being like the most important thing in the world at the beginning of the project. And I said, you're never going to do that. And they never did, actually, but they wanted to know how to do it. And when I told them, they said that was too hard to do. So then they never did it. And if you look at companies like GitHub, they're only on version 3. And they've been on version 3 for 10 years. So, you know what I mean? Like, think really hard when someone says, hey, we need to version our APIs. You say, okay, you think so, but then you never do it, right? Right? Let's see. Yeah, see, I think they're only on version 3, you know, and look at how long they've been on it. So they've been there, I think, forever on version 3. We had a guy come down and talk about the GitHub APIs, and he's like, it's just the way we do it is we just evolve them over time. They'll add a new API. So for example, I have an API called players, right? And what I might do is I might just add a new API, right? I don't need to remove that one. I might just add a new one and then remove the old one when it comes out. And that's where that metrics come in. So you have to like kind of, you know, remember who's calling what, so you can eventually move them off of that. And then use your documentation that you're providing for people to change it. So it's tricky and nuanced too, I think. Okay, Swami.
Yes, sir. I think there are no more queries. I think Sharad said yes, it makes sense. And I think that's it, Steve. for this session. So we are done with 3 sessions, and guys, thank you so much. And Steve, I really appreciate. Thank you so much for waking up early in the morning and taking this session. And we would love to have a session next month also, if you have some time. We'll see to host you.
Sure.
Sure. So thanks so much, and really hope folks would have learned something new. Let's meet again in next month's session. Thank you guys, and thank you so much. Thank you, Steve. You have
You're
a
welcome. See you later.
yeah. See you. Bye.
Bye.